Hello and welcome to Sleepy Science. Tonight, we are going to explore the one thing you can never escape, never hold, and never truly understand. Time. It bends near black holes, hides inside your body, stretches in fear, disappears in beauty, and turns everything you love into memory. But what if time is not what it feels like at all? Before we begin, tell me in the comments where you are watching from and what time it is there right now. And if you enjoy calm science that makes reality feel stranger, don't forget to like the video. Why time may not actually flow. What if the deepest illusion in your life is not what you see, but the fact that you feel time moving at all? You wake up, you grow older, the light shifts across the room, a song begins and ends, and everything inside you insists that time is flowing like an invisible river, carrying you from yesterday into tomorrow. It feels obvious, it feels impossible to doubt, but physics has a way of taking the most familiar things and turning them quietly inside out. When scientists describe time at the deepest level, they do not always describe it as something that moves. They describe it more like a dimension, woven together with space into one larger structure called space-time. In that picture, time is not necessarily a current rushing past you. It may be more like a direction in the fabric of reality, similar in some ways to left and right, up and down, near and far. You do not say that space is flowing because a mountain is north of you, or a city is behind you. Those places simply exist in relation to where you are. And according to one powerful interpretation of modern physics, moments may be like that too. Your childhood, this present breath, and the distant future may not be passing in and out of existence like sparks in the dark. They may be arranged within space-time, each with its own location, each real in a way that feels almost impossible to accept from inside a living mind. This does not mean your experience is fake. It means your experience may be local. You are not floating above the whole structure, seeing every moment at once. You are inside it, moving along your own path through it, like a small lamp traveling down a long corridor, lighting only one section at a time and calling that section now. The strange part is that physics does not give everyone the same now. Before Einstein, it seemed natural to believe there was one universal present, one cosmic clock ticking behind all events, deciding what was happening everywhere at the same instant. But relativity weakened that idea. Two observers moving differently can disagree about whether two distant events happened at the same time, and both can be correct within their own frame of motion, not because one of them is confused, but because simultaneity itself is not absolute. The universe does not appear to keep a single master clock for everything. It gives each observer their own slice of time, their own way of dividing reality into past, present, and future. That is where the idea of flowing time begins to tremble. If there is no single universal present, then what exactly is flowing? Flowing compared to what? A river flows because water changes position over time. But if time itself flows, it would need another kind of time behind it to measure that flow. A second clock watching the first clock move. And then that second clock would need a third. The idea begins to collapse under its own weight. In science, clocks do not measure the speed of time flowing. They measure intervals between events. The swing of a pendulum, the vibration of atoms, the rotation of Earth, the changing position of hands on a dial. A clock is not catching time like a bucket catches rain. It is comparing one physical process with another. This is why some physicists and philosophers say that the flow of time may not be a feature of the universe itself, but a feature of how conscious beings experience change. The world changes. Events are ordered. Causes come before effects in the ordinary world we know, but the feeling that reality is sliding forward, moment by moment, may be something added by the mind, not something written into the external structure of nature. And this is not a small shift. It changes the emotional shape of existence. If time does not truly flow, then the past is not a place that has been destroyed. It is not burned away behind you. It may be unreachable, yes, but not necessarily unreal. And the future may not be a blank emptiness waiting to be created from nothing. It may be part of the same space-time structure, hidden from your current position, the way a valley is hidden behind a mountain. This view is sometimes called the block universe, a picture in which all moments are part of one four-dimensional whole. You do not experience the whole block at once, just as a character in a book does not experience every page at the same time. The character lives sentence by sentence, but the book, from the outside, contains the beginning, middle, and ending together. The danger is to take this metaphor too literally. Physics has not proven that life is a finished book in the emotional sense. It has not proven that your choices are meaningless, or that the future is already written in the way a script is written. What it has shown is subtler and more unsettling. The clean, common-sense idea of one flowing time, shared by the entire universe, does not survive contact with relativity. Time is more flexible, more relational, and more mysterious than your everyday instincts suggest. And maybe this is why the question feels so haunting. You cannot step outside time to inspect it. Every thought you have about time happens inside time. Every doubt, every sentence, every heartbeat is already part of the thing you are trying to understand. You are like a wave trying to understand the ocean while still rising and falling within it. Yet there is something strangely peaceful in this. If time is not a river stealing everything from you, then maybe existence is not only a disappearance. Maybe moments are not simply vanishing the instant they arrive. Maybe they have a kind of quiet place in the larger structure of reality, even after you can no longer touch them. The evening you thought was gone, the voice you miss, the version of yourself you outgrew. The ordinary day you did not know you would later treasure. Perhaps none of it was ever held in the way your heart wanted, but perhaps none of it was merely nothing either. You live as if the present is all that exists, because that is the only window you are given. But beyond that window, time may be less like a river and more like a landscape, vast, silent, and already deeper than movement. And as you sit here, listening, breathing, feeling 1 second soften into the next, the mystery is not that time flows. The mystery is that something inside you feels it flowing and calls that feeling life. The strange reason the past feels real, but the future feels open. There is a quiet reason yesterday feels solid in your hands, while tomorrow feels like mist waiting to take shape. You can close your eyes and return to a room you once stood in, a face you once loved, a sentence someone said years ago that still lives somewhere in your chest. The past feels heavy because it has left marks. It has carved traces into your brain, into your body, into the world around you. A photograph on a table, a scar on your skin, a habit you never meant to build, a fear you still carry without knowing exactly when it began. All of these are fingerprints of what has already happened. The future does not leave fingerprints yet. It has no photograph, no scar, no confirmed shape. And because of that, it feels open, even when you know some things are likely. Even when tomorrow's sunrise is almost certain. Even when your routine seems ready to repeat itself. The strange difference is not that the past is magically more real than the future in every possible sense. The difference is that the past has evidence, while the future has expectation. Your brain is built to live inside that imbalance. It stores what has already touched you, then uses those stored pieces to predict what might come next. Memory and imagination are not separate kingdoms in the mind. Neuroscience shows that remembering the past and imagining the future use many overlapping brain systems, especially networks connected to memory, planning, and self-reflection. When you picture a future conversation, your brain often rebuilds fragments from old conversations. When you imagine a place you have never been, your mind borrows walls, skies, streets, faces, and emotions from places you have known. The future feels open because your brain is not retrieving it, it is constructing it. It is running quiet simulations, testing possible versions of what may happen, like a lantern moving through fog and revealing not one road, but several half-formed paths. This is one of the most important things to understand about human time. You do not experience the past as pure truth, and you do not experience the future as pure emptiness. You experience both through the brain's storytelling machinery. The past feels real because memory gives it texture, but memory is not a perfect recording. Every time you remember something, your brain can slightly reshape it, blending fact with emotion, later knowledge, and the meaning you now give it. That is why the same event can feel different after a year, after an apology, after a loss, after you grow into a different version of yourself. The event may be over, but its meaning can still move. The future, on the other hand, feels open because it has not yet been narrowed by consequence. Before a choice is made, many possibilities can sit together in the mind. You can imagine speaking or staying silent, leaving or remaining, beginning again or repeating the same pattern. But once action happens, the world answers. Possibility becomes result. Result becomes memory. Memory becomes part of the past's weight. This is why regret can feel so sharp. It is not only sadness over what happened, it is the pain of realizing that many imagined futures collapsed into one actual past. Before the decision, life felt wide. After the decision, it feels written. But even here, you have to be careful. The past may feel fixed, but your relationship to it is not. And the future may feel open, but it is not completely unlimited. You cannot become anything in any direction without conditions. Biology, history, environment, other people, chance, and the laws of nature all place boundaries around what is possible. The future is open, but not infinite. It is more like wet clay than empty air, flexible, but shaped by what came before. Your childhood, your habits, your body, your culture, your fears, your skills. These do not decide everything, but they influence the range of what becomes easier, harder, more likely, or nearly impossible. That is why time feels personal. You do not face the future as a blank creature. You face it as someone already formed by traces. And yet there is still room. Not endless room, but real room. The brain is predictive, but it can update. Habits are strong, but they can loosen. Memories can hurt, but they can also be reinterpreted. A future you once could not imagine can slowly become ordinary if you take enough small steps toward it. This is where the mystery becomes useful, not just philosophical. The reason the past feels real is that it teaches. The reason the future feels open is that it invites. One gives you evidence, the other gives you responsibility. If you only lived in the past, you would be trapped inside what already happened. If you only lived in the future, you would dissolve into fantasy and fear. Human consciousness seems to stand between the two, holding memory in one hand and possibility in the other. That is why the present feels so emotionally charged. It is the place where stored experience becomes future action. A word you choose now can become someone else's memory later. A small act of courage today can make a future version of you feel less impossible. A repeated thought can become a belief, and a repeated belief can become a life. The past feels real because it has already entered the world. The future feels open because it is still waiting for the world to answer what you do next. And maybe this is why time feels both comforting and terrifying. You are surrounded by things that cannot be undone, while moving toward things that cannot be fully known. You are made of yesterday but not sealed by it. You are reaching toward tomorrow, but never holding it completely. And somewhere in that fragile space between evidence and possibility, your life quietly unfolds, not as a perfect plan, not as a finished story, but as a living negotiation between what has marked you and what you still dare to change. How gravity can bend time itself. A clock at your feet is not aging at exactly the same pace as a clock near your head, and that tiny difference is one of the strangest clues that gravity does not simply pull on objects. It reaches into time itself. It sounds almost too quiet to be true because you do not feel time stretching under you when you stand on the ground. You feel weight. You feel the floor holding you up. You feel your body pulled toward Earth as if gravity were only a downward force, a kind of invisible hand pressing everything into place. But Einstein changed that picture. In his view, gravity is not just something that drags objects through space. Gravity is the shape of space-time, the deep fabric in which space and time are woven together. A planet, a star, or even your own body does not merely sit inside the universe like an object placed on a table. It changes the geometry around it. It curves the paths that moving things follow. And because time is part of that same geometry, gravity changes the rhythm of time as well. Near a massive object, time runs slightly slower compared with a place farther away from that mass. This is not a metaphor, it has been measured. Put one extremely precise atomic clock closer to Earth and another one higher up, even by a small distance, and the higher clock ticks a little faster. The difference is tiny in everyday life, so small that your senses could never catch it. But it is real enough that modern technology has to account for it. The satellite systems that help phones, cars, aircraft, and ships find their location depend on clocks in orbit. Those clocks do not tick at exactly the same rate as clocks on Earth's surface, partly because they are moving fast, and partly because they are farther from Earth's gravity. If engineers ignored these effects, navigation errors would build up quickly. So every time a map on your phone calmly tells you where you are, it is quietly relying on the fact that time is not the same everywhere. The deeper you are in a gravitational field, the slower your time passes relative to someone higher up. This is called gravitational time dilation, but you do not need the name to feel the wonder of it. Imagine time as a song played across the universe. Gravity does not stop the music, it changes the tempo. Near Earth's surface, the beat is just a little slower than it is above. Near a much denser object, the difference becomes more dramatic. Time is not breaking, it is following the shape of reality. This means that time is not some perfect cosmic metronome ticking the same way for every place, every person, every star. It is local. It is affected by where you are and by the mass around you. The clock does not only belong to the machine on the wall, it belongs to the world it is sitting in. This idea can feel unsettling because it removes one of the quiet assumptions behind ordinary life. You are used to thinking that time is the one thing everyone shares equally. People may have different bodies, different memories, different futures, different distances to travel, but surely 1 second is 1 second. Yet relativity says a second is not simply handed down from the universe as an absolute gift. It depends on the path you take through space-time and the gravitational environment you inhabit. A second near Earth's surface and a second far away in deep space are not perfectly identical when compared carefully. They are both real, both correct from their own location, but they do not match exactly. The universe is not unfair when it does this. It is consistent in a deeper way than common sense expected. Gravity bends time because gravity bends the structure that time is part of. And perhaps the most beautiful way to understand it is not to picture time as a separate river flowing through the cosmos, but as something stitched into the same fabric that lets planets orbit. Light curve and falling objects trace their paths. When light passes near a massive star, its path can bend, not because the star reaches out like a hook, but because the space around the star is curved. In a similar way, time near mass is shaped by that curvature. The closer you are to the source of gravity, the more your clock is pulled into a slower rhythm compared with someone farther away. You do not notice this while making breakfast, walking down a street, or lying in bed at night, because Earth's gravity is gentle compared with the extremes of the universe. But the effect is always there, hidden beneath ordinary experience. Even your body exists across a faint gradient of time. Your head, being slightly farther from Earth's center than your feet, ages by an unimaginably small amount more over a lifetime. It is not enough to matter biologically, but it is enough to reveal something profound. You are not only living in time, you are living through a layered structure of time, a structure shaped by the planet beneath you. This turns gravity into something more intimate than weight. It means the ground under your feet is not just holding you down, it is subtly changing the pace at which your moments unfold. The mountain, the ocean, the planet, the star, each one leaves a signature on time. And this is where science begins to feel almost philosophical without needing to become fantasy. If time can bend, then your sense of a simple, uniform reality was always incomplete. The universe is not a flat stage where events happen against the same background clock. It is more like a living landscape of rhythms, where every massive thing shapes the timing of everything nearby. A clock in a valley and a clock on a mountain are not disagreeing because one is flawed. They are telling the truth from different depths of gravity. And you, standing somewhere between Earth's center and the open sky, are part of that truth. Your life unfolds at the tempo of your place in the cosmos. This does not make your days less real. It makes them more deeply connected to the physical world than they first appear. Every second you feel passing is not just a private sensation inside your mind. It is also a local event in space-time, tuned by gravity, position, motion, and mass. The ordinary clock becomes a kind of translator. It does not command time. It reveals the rhythm of the region it occupies. And maybe that is the quiet lesson hidden here. Even time, the thing you trust most without seeing it, is shaped by what surrounds it. Nothing exists completely alone. Not planets, not light, not clocks, not you. The next time you feel the weight of your own body, the pull of Earth beneath your bones, you might remember that gravity is doing more than anchoring you to the ground. It is bending the invisible architecture of your moments. It is slowing the song by a fraction too small to hear, but real enough to guide satellites, bend starlight, and change the meaning of a second. And in that softened understanding, time stops feeling like a distant ruler above existence. It becomes part of the world's texture, folded gently around matter, wrapped around stars and planets, and passing through you not as something separate from the universe, but as one of the ways the universe quietly holds itself together. Why astronauts age slightly differently in space. An astronaut can leave Earth, circle the planet thousands of times, return home smiling, and still have lived through a slightly different amount of time than everyone who stayed below. Not in a dramatic science fiction way, not enough to see in the mirror, not enough to make one person suddenly young while another grows old, but enough to prove that aging is not as simple as a calendar counting days. Your body ages by following the time along your own path through the universe, and an astronaut's path is not the same as yours. Down here, you may think of time as something shared equally by everyone. 1 second for you, 1 second for me, 1 second for the person watching the sky from a window. But spaceflight quietly breaks that assumption. When astronauts live aboard the International Space Station, they are not just up there floating above Earth. They are moving around the planet at enormous speed, roughly circling Earth every 90 minutes. That speed matters. According to Einstein's relativity, the faster you move through space compared with someone else, the slower your time passes relative to theirs. Again, this does not mean the astronaut feels slow. Inside the spacecraft, their heartbeat, thoughts, meals, sleep, and conversations all feel normal. Their watch seems to tick normally beside them. Time only appears different when their path is compared with someone else's path back on Earth. This is the quiet heart of the mystery. Time does not feel strange to the person living inside it. It only becomes strange when two lives reunite and compare their clocks. For astronauts in low Earth orbit, two effects are happening at once. Their high speed makes them age slightly slower than people on Earth, while being a little farther from Earth's surface slightly changes the gravitational effect on their time in the opposite direction. These two influences do not cancel perfectly. For astronauts aboard the space station, the speed effect is usually stronger, so they return having aged a tiny bit less than they would have if they had stayed on the ground. The difference is measured in fractions of a second, often milliseconds over long missions, but the smallness is not the point. The point is that the difference exists at all. Nature is telling you that age is not only biology, it is also geometry, motion, and the route your life takes through space-time. Your birthday counts how many times Earth has gone around the sun since you were born, but your actual aging is written more subtly, inside the physical path your body follows. Every cell in you is moving through the universe, and every clock is loyal to the journey it takes. This is why the famous twin idea is so powerful. One twin stays on Earth, the other travels very fast through space and returns younger than the one who stayed behind. In real astronaut missions, the difference is tiny, because our spacecraft are still slow compared with the speed of light. But if a future spacecraft could travel incredibly fast for a long time, the difference would grow. A traveler might experience a few years while many more years pass on Earth. This is not fantasy in the basic physics. The challenge is engineering. Reaching such speeds would require energy and technology far beyond what we currently use. Still, the principle is real, and it has already been confirmed not only through spaceflight, but also through precise experiments with atomic clocks on aircraft and satellites. Clocks that take different journeys do not always agree when they meet again. That sentence sounds almost gentle, but it changes something deep in how you understand existence. You are not aging inside one universal container called time. You are aging along your own world line, your own thread through the fabric of reality. The astronaut's thread loops rapidly around Earth. Yours may remain on the surface, carried by the planet's rotation, its orbit around the sun, and the motion of the solar system through the galaxy. Both lives are real. Both feel ordinary from the inside, but they are not identical paths, and the universe keeps track. This makes space travel strangely intimate. We often think of astronauts as exploring distance, crossing height, escaping gravity, entering silence, but they are also exploring time, even when the difference is too small to notice. Every orbit is a tiny experiment in what it means to age. Every return to Earth is also a reunion between clocks that have not lived the same story. And maybe this is why the idea feels so haunting. It reminds you that time is not merely something you endure. It is something your body participates in. Your aging is not only the result of years passing over you like weather, it is the sum of motion, gravity, chemistry, memory, sunlight, sleep, and the fragile rhythm of cells repairing themselves imperfectly through the years. Space reveals the physical side of that rhythm with unusual clarity. It shows that even a human life, something that feels emotional and private, is still woven into the deepest rules of the cosmos. The astronaut looking down at Earth is not outside time. They are inside a slightly different version of it, carried by speed, orbit, machinery, and the blue planet turning beneath them. And when they come home, the difference may be too small for the heart to feel, but not too small for reality to record. That is the quiet wonder. Two people can separate, live for months under the same stars, and return with time itself having treated them differently. Not because time is unfair, but because time is personal to the path. And perhaps your own life is like that too. Every choice moves you through a different route, not always changing your age by physics in any noticeable way, but changing the texture of the years you become. An astronaut ages slightly differently because the universe is not ruled by a single, simple clock. It is filled with clocks carried by bodies, planets, machines, and hearts, each one ticking faithfully along its own journey through the dark. The mystery of why we can remember the past, but not the future. The future may be in front of you, but your brain can only hold fingerprints from the direction where the universe has already left evidence behind. You remember your first room, a painful goodbye, the smell of rain on a certain street, the voice of someone who once said your name in a way that never fully disappeared, but you do not remember tomorrow. You may expect it, fear it, plan it, rehearse it, even dream about it, yet it never arrives in the mind with the same authority as a memory. And the reason is deeper than psychology. It reaches into the way the universe stores information. A memory is not simply a thought floating inside your head. It is a physical trace. When something happens to you, light enters your eyes, sound reaches your ears, pressure touches your skin, chemicals shift in your body, and patterns of activity move through your brain. Some of those patterns fade almost instantly. Others are strengthened through attention, emotion, repetition, and sleep. The hippocampus, a structure buried deep in the brain, helps bind pieces of experience together, place, feeling, sequence, meaning, so that later, when you recall the event, your brain can rebuild a version of it. That rebuilding is imperfect, but it is still based on traces that were created after something occurred. This is the simple, strange foundation. To remember, the world must first leave a mark. The future has not left marks yet. It has not pressed itself into your nervous system. It has not scattered records into photographs, scars, documents, fossils, brain pathways, or changed rooms. You can predict the future because the past has given you patterns, but prediction is not memory. A prediction points forward from evidence. A memory points backward toward evidence, and that difference exists because the universe itself seems to have an arrow. At the deepest level, many physical laws can work in both directions on paper, but the world we actually live in does not feel reversible. Smoke spreads through a room, but does not gather itself neatly back into a candle flame. Heat moves from hotter things toward colder things, not the other way around in ordinary life. A footprint appears after a foot presses into sand, not before. These are not just everyday accidents. They are connected to entropy, the tendency for energy and matter to become more spread out and less neatly arranged over time. Because entropy increases, records are easier to form in one direction. The past can leave evidence in the present, while the future cannot send back ordinary physical traces for your brain to store. This is why you can know that a tree once grew from a seed by reading its rings, or that rain fell by seeing wet pavement, or that someone walked through dust by seeing their trail. The present is filled with records of what came before. It is not filled with reliable records of what has not yet happened. Your mind is part of this same structure. It is not a magical observer standing outside nature. It is a recording system built from matter, and matter records the past because the universe's arrow allows traces to accumulate behind events. This also explains why memory feels so tied to identity. You do not just know facts about yesterday. You carry physical changes from yesterday. Your brain has been shaped by every repeated action, every danger survived, every kindness received, every loss absorbed. You are not remembering the past from a distance. You are partly made of its records, but the future enters you differently. It arrives as simulation. Your brain takes fragments of memory and rearranges them into possible scenes, not because it can see ahead, but because it evolved to prepare. An animal that can anticipate winter, danger, hunger, or social rejection has a better chance of surviving than one that only reacts after everything happens. So the brain became a prediction machine, always leaning forward, always using old evidence to guess the next movement of the world. This can feel almost supernatural when your guesses are right, but it is not future memory. It is pattern recognition. It is the brain saying, something like this has happened before, so something like that may happen next. And sometimes it is wrong, because the future is not stored. It is inferred. This is why anxiety can be so convincing. The mind can build a future scene with enough detail that the body reacts as if it were already real. The heart tightens, the stomach drops, the muscles prepare. But no matter how vivid it feels, it is still not a memory. It has no actual event behind it yet. It is a forecast wearing the emotional weight of experience. And this is where the mystery becomes personal. You live between records and possibilities. Behind you are traces you cannot erase completely. Ahead of you are outcomes you cannot remember because they have not carved themselves into the world. You are allowed to learn from the past, but not to possess the future. You are allowed to prepare, but not to know. And maybe that limitation is not only a weakness. If you could remember the future the way you remember the past, choice might feel like a performance already completed. Surprise would vanish. Hope would become a kind of archive. Fear would harden into certainty. But because the future is hidden from memory, life remains open enough for attention, effort, and courage to matter. You move forward without a record from tomorrow, guided only by the traces of what has been and the quiet intelligence of what might be. The past is remembered because it has touched the world and left evidence inside you. The future is unknown because it has not yet become physical enough to leave a trace. And so you stand in the only place a conscious creature can stand, surrounded by echoes, facing silence, carrying a brain built from yesterday, while stepping into a tomorrow that has not yet learned your name. Why time feels faster as you get older. One day, without warning, summer stops feeling endless. Birthdays arrive too quickly, and an entire year begins to disappear behind you, like a door closing before you even heard it open. When you are a child, time feels wide because almost everything is new. A walk to school is not just a walk. It is a field of details your brain has not yet learned to ignore. The shape of cracks in the pavement, the smell of a classroom, the unfamiliar face of a teacher, the strange pressure of being seen by other children. The first time you hear a song, the first time you lose something, The first time you understand that a day can hurt. Novelty makes the brain pay attention, and attention gives time texture. A new experience is rich with information, so when your mind stores it later, it leaves behind many markers. Looking back, that period feels longer because there is more to remember. But as you grow older, the world becomes more familiar. Your brain becomes efficient. It stops recording every hallway, every commute, every repeated breakfast, every familiar road. It compresses routine. And that compression is one of the quiet reasons life seems to accelerate. The day itself may not feel fast while you are living it. Sometimes work is slow, waiting is slow, boredom is painfully slow. But when you look back, repeated days blur together because they did not create many distinct memories. A week of routine can collapse into a single vague shape. A month of similar mornings can feel like it vanished. The brain does not keep time like a perfect camera. It builds your sense of duration partly from change, contrast, emotion, and memory density. This is why a short trip to a new city can feel longer in memory than an entire ordinary month at home. The trip forced your mind awake. It gave you new streets, new sounds, new problems, new surprises. Routine, on the other hand, lets consciousness run on shortcuts. This is useful for survival. If your brain treated every familiar object as completely new, life would be exhausting. You would spend your energy rediscovering your kitchen every morning. So the mind learns what can be ignored. It predicts, it filters, it saves effort. But the cost of that efficiency is strange and emotional. The more predictable your life becomes, the faster it seems to vanish when you look back. There is also another reason childhood feels longer. A year to a 5-year-old is an enormous portion of life, but a year to a 50-year-old is much smaller compared with everything already lived. The same amount of calendar time occupies a different emotional scale. Childhood years feel large because they stand against a small background. Later years are placed against a much larger inner landscape. So each one can feel thinner, quieter, easier to lose among the others. This is sometimes called the proportional explanation of time perception. And while it does not explain everything, it captures something deeply intuitive. Time is not only measured by clocks, but by the size of the life that surrounds it. Yet the feeling of faster time is not only about age, it is also about attention. When you are fully absorbed in an activity, time may seem to disappear while you are doing it. Hours can pass unnoticed. But afterward, if the experience was rich and meaningful, it may feel large in memory. The opposite can also happen. A boring hour can feel heavy while you are trapped inside it, but almost empty when you remember it later. This means there are two kinds of time in your mind: the time you feel while living and the time you feel when remembering. They do not always agree. A difficult afternoon can feel endless in the moment and yet leave almost no trace. A beautiful conversation can feel too short while happening, then expand inside memory for years. Aging changes your relationship with both. Adults often live with more responsibility, more schedules, more repeated obligations, and less unstructured wonder. The mind is busy but not always awake. Days fill up, but not always with things that make them distinct. And so life can become crowded without becoming memorable. This is why the years can feel as if they are speeding up even when you are exhausted by them. The calendar is full, but the memory is thin. There may also be changes in the brain's internal timing systems as we age. Changes in attention, arousal, dopamine, and how quickly we process information. But scientists are careful here. There is no single switch that makes older people experience time faster. It is a mixture of biology, psychology, memory, routine, emotion, and comparison. Time does not simply accelerate inside the universe as you age. Rather, your mind builds a different relationship with it. And that difference can be frightening because it makes life feel fragile. You begin to realize that time is not only something you spend, it is something you notice or fail to notice. A year can pass through you almost silently if nothing interrupts the pattern. But this also means the feeling of acceleration is not completely beyond your influence. You cannot become a child again, and you cannot make years objectively longer, but you can make them denser. You can give the mind more markers, learn something unfamiliar, walk a different route. Pay attention to the season changing before it is gone. Have conversations that do not sound like every other conversation. Put your phone away long enough for a moment to become real. Do things that make the brain stop predicting and start receiving again. Novelty does not have to be dramatic. It can be a new book, a new skill, a new place in your own city. A deeper question asked to someone you thought you already knew. What matters is that the mind wakes up, because when attention returns, time becomes textured again. The tragedy is not that life gets shorter as you age. The tragedy is that familiarity can make it feel unseen. And maybe the quiet invitation hidden inside this strange feeling is not to panic at the speed of years, but to stop letting them pass without shape. Time feels faster as you get older because your brain has learned the world too well. So perhaps the answer is to become, in some small way, a beginner again, to let ordinary light surprise you, to let one day stand apart from the others, to live so that when you look back, the year does not appear as a blur, but as a landscape with paths, colors, voices, and moments that were fully allowed to leave a mark. How your brain creates the feeling of now. Your now is not a point in time you simply touch. It is a scene your brain quietly assembles after the world has already arrived in pieces. Right now, as you listen, it feels as if everything is happening together. The sound of these words, the weight of your body, the dimness of the room, the rhythm of your breathing, the faint awareness of your own thoughts. It feels unified, immediate, effortless. But beneath that smooth feeling, the brain is doing something astonishing. It is collecting signals that do not arrive at the same speed, processing them through different pathways, correcting delays, matching fragments, and stitching them into one believable moment. Light reaches your eyes and sound reaches your ears, but your brain does not handle them in exactly the same way. Touch, vision, hearing, balance, body position, and emotion all require different kinds of processing. Some signals move quickly, some take longer, some are sharpened by attention, some are softened into background, yet you do not experience life as a pile of delayed signals. You experience a present. That is because the feeling of now is not raw reality entering you untouched. It is a carefully edited integration window, a short span of time in which the brain gathers nearby events and treats them as belonging together. Scientists sometimes describe this as the specious present, the brief duration that feels like the present moment even though it is not infinitely thin. Your mind needs this little window because consciousness cannot work like a camera flash, capturing one frozen instant after another. It needs continuity. It needs enough time to connect a word to its meaning, a facial expression to an emotion, a movement to its cause. If the brain treated every tiny instant as separate, experience would shatter into fragments. You would not hear a sentence. You would hear disconnected sounds. You would not see a hand wave. You would see isolated positions. You would not feel like a self moving through a moment. You would feel like sparks of sensation with no thread between them. So the brain gives you a usable present, not a perfect one. It blends information across fractions of a second, smoothing the edges so reality can be lived instead of merely sampled. This is why timing illusions can happen. In certain experiments, a sound and a flash can be perceived as happening together, even when they are slightly offset, because the brain decides they are close enough to belong to the same event. In daily life, this is not a flaw. It is what lets you function. When someone speaks, your brain aligns the movement of their lips with the sound of their voice. When you catch a falling cup, your brain combines sight, motion, expectation, and muscle response so quickly that the act feels instant. But it is not truly instant. It is coordinated. The present is a negotiation between incoming sensation and prediction. Your brain is not waiting passively for the world to finish speaking. It is constantly guessing what is about to happen, then correcting itself when new information arrives. This predictive ability is one reason life feels smooth. You do not only see where a moving object was, your brain estimates where it is likely to be by the time you respond. You do not only hear sounds as vibrations, your brain organizes them into language, warning, music, distance, intention. The now you feel is partly built from what is arriving and partly from what your brain expects should be arriving next. This can feel unsettling because it means your most intimate sense of reality is already an interpretation, but it is also deeply practical. The brain is not trying to deceive you. It is trying to keep you alive inside a world that changes faster than awareness can fully capture. A purely accurate present might be too slow to be useful. A constructed present lets you move, speak, react, understand, and belong. Even your sense of self depends on this construction. You feel like one continuous person because the brain binds body signals, thoughts, emotions, and attention into a single living frame. Hunger belongs to you. A memory flicker belongs to you. A decision forming in the mind belongs to you. The brain gathers these different currents and says quietly, "This is me, here, now." And yet, that now is fragile. It can stretch during intense focus, blur during exhaustion, fracture under trauma, deepen in meditation, or dissolve at the edge of sleep. The present is not a fixed object sitting inside the skull. It is an active process, renewed again and again, like a flame that looks steady only because it is constantly being remade. And perhaps that is the most haunting part. You never meet the world in a pure, untouched instant. You meet the version of the world your brain has made coherent enough for you to survive. The present moment feels simple because the work behind it is hidden. It feels immediate because the delay is covered. It feels solid because your mind has learned how to weave time into experience. So when you say now, you are naming something far more mysterious than a second on a clock. You are naming a small miracle of timing, prediction, sensation, and awareness. A living doorway where the outside world becomes inner life, and where scattered signals become the quiet feeling of being here. Why the present moment may already be gone. By the time the world reaches your awareness, it has already moved on without you. The face in front of you, the lamp beside your bed, the hand you raise into the air, the quiet shadow crossing the wall, none of it arrives in consciousness at the exact instant it happens. It feels immediate because the mind protects you from the delay, but the delay is always there. Light must travel from an object to your eyes. For things nearby, that journey is so fast it feels like nothing, but it is still not zero. The sunlight on your skin is already about 8 minutes old by the time it reaches Earth. The stars are not seen as they are now, but as they were years, centuries, or sometimes thousands of years ago. Even the moon you look at is a little over 1 second in the past. This is not a poetic idea. It is the simple consequence of light having a finite speed. To see anything is to receive news from an earlier version of it. And after that light reaches your eyes, the story is still not finished. Your retina has to convert light into electrical signals. Those signals have to travel through the optic nerve. The brain has to sort edges, movement, color, depth, shape, and meaning. It has to decide that this pattern is a face, that this movement is a threat, that this blur is your own hand, that this sound belongs to the thing you just saw moving. All of this takes time, usually only fractions of a second, but enough to prove that your conscious present is not perfectly synchronized with the external world. You are not living inside raw reality. You are living inside a carefully updated report about reality, delivered slightly late. This delay is not a mistake. It is the price of having a nervous system. A brain that processes information instantly would need to break the limits of biology. Instead, your brain survives by being clever. It does not wait helplessly for the world to fully arrive. It anticipates. When a ball flies toward you, your brain does not only register where it was a moment ago, it estimates where it is going, prepares your muscles, and lets you react to a future position based on past information. When you walk through a room, you do not calculate every object from scratch. Your brain uses expectation, memory, and movement to keep the world feeling stable. In a sense, you are always standing between two ghosts: the immediate past that has reached your senses, and the near future your brain is predicting so you can act in time. This is why the present can feel so solid even though it is built from delay. Consciousness is not a perfect live broadcast. It is more like a broadcast corrected just enough that you can move through the world without noticing the lag. And sometimes, the hidden delay reveals itself. You turn your head quickly and the world seems to remain stable, even though the image on your retinas is shifting wildly. You clap your hands and experience sound and touch as one event, even though different signals travel and process at different speeds. You watch a distant firework and see the explosion before you hear it, because light outruns sound. In extreme cases, the gap becomes obvious. But in ordinary life, the brain smooths it away, because noticing every delay would make reality feel fractured and difficult to navigate. The unsettling truth is that right now may never be something you directly possess. By the time you become aware of a moment, the physical event that caused that awareness has already passed into the next state of the world. Your awareness is always arriving just behind the event, like a quiet echo following a footstep. This does not mean life is unreal. It means life is mediated. It means every sight, every sound, every touch is a message from the recent past, interpreted by a brain trying to keep you alive in the moving present. And once you understand this, the world becomes stranger in a very gentle way. A conversation is not two minds meeting in a perfect instant, but two nervous systems exchanging delayed signals and still somehow creating intimacy. A kiss is not timeless because it escapes time, but because the brain gathers touch, warmth, breath, and emotion into a moment rich enough to feel whole. Even looking into a mirror is not seeing yourself exactly now. It is seeing light that left your body a tiny instant earlier, bounced from the glass, entered your eyes, and became a version of you inside the brain. The delay is impossibly small, but the meaning is enormous. You have never seen yourself in the absolute present. You have only seen the nearest past your senses can deliver, and maybe this is why presence feels so precious. It is not the ownership of a perfect instant. It is the act of turning your attention toward a world that is always slightly ahead of your awareness, and loving it anyway. You reach for reality knowing it cannot be fully caught. You listen to a voice already fading into memory. You watch light that began its journey before you noticed it. You live inside a thin and tender delay, close enough to touch the world, but never close enough to freeze it. The present moment may already be gone by the time you feel it, but the feeling itself is how the universe lets you meet what has just passed, softly, briefly, and almost in time. The strange link between time and entropy. Time may feel like an invisible road beneath your life, but entropy is the reason that road seems to have a direction at all. Without entropy, the universe would be far stranger than a world without clocks. It would be a world where before and after might lose much of their meaning. You would still have events, motion, particles, forces, and change. But the deep difference between a beginning and an ending would become much harder to explain. In everyday life, the direction of time feels obvious because certain things happen one way and almost never the reverse. A hot drink cools on the table. A scent spreads through a room. A carefully stacked pile of papers becomes messy when scattered by the wind. Food changes as it cooks. Metal slowly rusts. Living bodies grow, heal, tire, and age. These are not just random examples of things changing. They point toward a deeper pattern. Energy and matter tend to move from more concentrated, more specially arranged states toward more spread out, less specially arranged states. That tendency is what entropy describes. Entropy is often called disorder, but that word can be misleading if you take it too simply. A better way to think of it is possibility. A low entropy state is special because there are fewer ways for it to be arranged. A high entropy state is common because there are many more ways for it to be arranged. A deck of cards in perfect order is rare, not because the universe dislikes order, but because there are vastly more ways for the cards to be mixed than neatly sorted. A drop of ink sitting in one small corner of a glass of water is a special arrangement. Once it spreads everywhere, there are far more microscopic ways for the ink and water to be mixed than separated. Nothing magical has forced the ink to choose chaos. It has simply moved toward the kind of arrangement that is overwhelmingly more likely. This is the quiet power of entropy. It turns time's arrow into a matter of probability. At the deepest physical level, many microscopic processes do not obviously care which direction you call past or future. If you could watch a tiny collision between two particles, The laws describing that collision may often work just as well forward or backward. But when you zoom out from a few particles to countless particles, statistics takes over. The universe begins to show a preference, not like a conscious decision, but like an ocean made from numberless drops. Each small interaction may be reversible in principle, but the whole system almost always drifts toward the arrangements that have more possible ways to exist. That drift is what gives the world its irreversible feeling. This is why entropy is so deeply linked to time. Time itself is not the same thing as entropy, but the direction in which entropy increases is the direction we call the future. You do not need an equation to feel how radical that is. The future is not just what comes next on a clock. It is the direction in which usable energy becomes less concentrated, arrangements become less special, and traces of events accumulate. A candle burns because stored chemical energy is released into light and warmth, spreading into the surroundings. A battery drains because organized energy is converted into forms that are harder to gather back. Your body stays alive by constantly taking in ordered energy from food and sending out heat and waste into the environment. Life does not violate entropy. Life survives by riding the flow of entropy, building temporary islands of order while increasing disorder around itself. Every heartbeat, every thought, every repair inside a cell depends on energy passing through you. You are not a machine standing outside the arrow of time. You are one of its most delicate consequences. The reason your body can maintain its structure is because it exchanges energy with the world, taking in what is useful and releasing what is no longer concentrated enough to serve the same purpose. In that sense, living things are not exceptions to entropy. They are beautiful negotiations with it. But entropy does not only explain why processes have direction, it also helps explain why the past seems filled with records. A record is a physical trace, a mark, a memory, a fossil, a photograph, a changed state somewhere in the world. For a record to exist, something must have interacted with something else and left a more spread out pattern of information behind. When light reflects from a face into a camera, when pressure leaves a mark in soft ground, when experience changes connections in the brain, the universe has made a trace by changing physical systems. These traces point one way because they are produced as entropy increases. You find evidence of yesterday because yesterday has already spent energy leaving marks. You do not find ordinary evidence of next year because next year has not yet produced those marks in your present surroundings. So the arrow of time is not only in clocks, it is in evidence, memory, aging, and cause. Entropy is why the world feels like a story instead of a shuffled pile of scenes. There was a very special early state, and everything since has been unfolding away from it. That early state is one of the greatest mysteries in physics. The young universe appears to have been extremely hot and dense, but in an important gravitational sense, it was also highly ordered, with matter spread very smoothly across space. That smoothness may sound like disorder, but for gravity, it is surprisingly special. Gravity tends to pull matter into clumps, stars, galaxies, and black holes. So a smooth early universe gave cosmic history room to develop. From that low entropy beginning came the long rise of structure. The first atoms, the first stars, the heavy elements made inside stars, planets, oceans, chemistry, cells, nervous systems, memory, and eventually, a creature like you asking why time moves the way it does. This is the astonishing connection. Your private feeling of time passing may be linked across billions of years to the strange low entropy condition of the early cosmos. The arrow in your life and the arrow in the universe may share the same root. Yet science is honest here. Entropy explains much about time's direction, but it does not fully explain why the universe began in such a special state. That remains one of the deepest open questions. Why was the early universe so ordered in the right way? Why was there an arrow ready to unfold? We do not know completely. And that not knowing matters, because it keeps the topic from becoming a simple answer dressed as mystery. Entropy gives us a powerful clue, not a final ending. It tells us that time's direction is connected to probability, energy, information, and the rare specialness of the beginning. It shows that the future is the direction in which the universe uses up concentrated possibilities and turns them into wider, softer, less recoverable patterns. And perhaps this is why time feels so emotionally heavy. Every moment is not only passing, it is becoming less easy to reverse. Every choice sends ripples into systems that cannot be perfectly reset. Every word spoken enters the air, the ear, the memory, the body, and becomes part of a changed world. Entropy does not make life meaningless. It makes it precious. It says that order is temporary, warmth spreads, structures fade, and moments cannot be held in their original form forever. But it also says that beauty exists because the universe began with room for change. Stars shine because energy flows. Bodies live because energy flows. Thoughts form because energy flows. Love matters because it appears briefly, locally, against a cosmic background that is always moving toward wider dispersal. So when you feel time carrying you forward, you may really be feeling the universe moving from rare arrangements into more common ones, from stored possibility into spent reality, from tension into release. And somewhere inside that great unwinding, you are given a small luminous interval in which energy gathers into awareness and looks back at the arrow that made it possible. Why broken things never reassemble themselves. A shattered glass on the floor contains a secret about the entire universe. Nothing in its pieces has forgotten how to obey physics, yet the whole will almost certainly never rise back into your hand. You know this so deeply that you do not even question it. If a cup falls, you expect sharp fragments, a sudden sound, a small silence afterward. You do not expect the fragments to slide together, the cracks to seal, and the cup to leap gently back onto the table. But why not? At first, the answer seems obvious. Broken things are broken. But physics asks a deeper question. The atoms inside the glass still exist. The energy is still somewhere. The pieces did not vanish into nothing. So why does the world allow breaking so easily, while unbreaking seems almost forbidden? The strange truth is that nature does not place a simple sign on the universe saying, things may break, but never repair themselves. At the smallest level, many motions can, in principle, be reversed. If you could track every atom in the glass, every vibration in the floor, every tiny wave of heat in the air, every sound ripple spreading outward, and then reverse all of them with perfect precision, the event could theoretically run backward. The fragments could reassemble. The sound could flow back into impact. The cup could return to its original shape. But that word perfect is where reality closes the door. A broken cup is not just a cup in pieces. It is an event that has spread information and energy into the surroundings. The crack pattern is in the fragments. The impact is in the floor. The sound has moved through the room. A little heat has been created. Tiny disturbances have traveled into the air, into the table, into your body as you flinch. To reverse the breaking, you would not only need to move the visible pieces, you would need to undo the entire web of consequences with impossible accuracy. One atom slightly wrong, one air molecule out of place, one vibration missed, and the repair fails. This is why broken things do not reassemble themselves in ordinary life. Not because reversal is logically unthinkable, but because the number of details that would need to line up is unimaginably vast. A whole cup is a very special arrangement. Its atoms are bonded in a certain structure. Its shape is continuous. Its surface holds together. Its handle is attached. Its strength comes from an organized pattern. A pile of fragments can be arranged in countless messy ways, but only a tiny number of arrangements count as the original cup restored. The broken state is not more powerful, it is simply more likely. Once the cup is scattered into many possible fragment positions, the chances of random motion producing the one exact path back to wholeness are so small that for real life, they are effectively zero. This same idea explains why an egg does not unscramble in a pan, why a collapsed sandcastle does not rebuild itself when the wind changes, why ash does not turn back into wood, and why time seems to carry damage in one direction. The universe is not being cruel. It is following probability across enormous numbers of particles. The more parts a thing has, and the more those parts interact with the world around them, the harder it becomes for the exact old order to return by accident. This is also why repair is possible but never free. A person can glue the cup, a machine can melt glass and reshape it, a living body can heal a cut, a city can rebuild after destruction. But all of these require energy, guidance, and structure. Repair happens when something uses organized effort to create local order again. Even then, the wider world pays a cost. The glue was manufactured. The furnace used fuel. The cells in a wound consumed chemical energy. The workers grew tired. Heat was released. Materials were moved. Order can be restored in one place, but only by drawing on energy and increasing disorder somewhere else. This is one of the quiet reasons life feels so fragile. It takes constant work to hold shape. Your body is not staying organized by accident. Every second, cells are repairing molecules, correcting errors, clearing waste, rebuilding tissues, and managing energy. Life is not a violation of decay. It is a temporary resistance pattern inside a universe where unattended order tends to loosen. A clean room becomes messy unless someone spends effort. A garden grows wild unless it is tended. A relationship weakens if care is never renewed. A memory fades if it is never revisited. The physical principle reaches into emotional life without becoming mystical. Delicate things need maintenance because the world does not preserve special arrangements for free. And this gives brokenness a different meaning. When something breaks, it is not only losing shape, it is becoming more spread into the world. Its former order has become traces, fragments, heat, sound, consequences. That is why loss feels irreversible too. A spoken word cannot be unspoken in the same clean way. It enters another mind, changes a mood, becomes memory, alters the next moment. You can apologize, repair, rebuild trust, but you cannot make the original unbroken state return as if nothing happened. The future can contain healing, but not erasure. This is not hopeless. In fact, it is what makes care meaningful. If broken things easily reassembled themselves, attention would matter less. If wounds closed without effort, gentleness would lose some of its weight. If the world reset itself perfectly after every mistake, responsibility would become thin. The fact that order is rare gives value to the hands that protect it. The fact that repair costs energy gives dignity to anyone who tries. So the shattered glass teaches more than physics. It teaches that wholeness is a special condition, not the default state of matter. It teaches that every intact thing around you, a cup, a home, a body, a friendship, a quiet evening, exists because countless details are, for now, holding together. And when you understand why broken things almost never reassemble themselves, the ordinary world becomes softer, more serious, more worthy of attention. You begin to see that nothing delicate remains whole by accident. It remains whole because forces have not yet scattered it, or because someone, somewhere, keeps choosing to hold it together. How the universe keeps its own clock. Long before humans drew clocks on walls, the universe was already keeping time in the quiet repetition of things that return. A planet turns, a moon circles, a star pulses, an atom changes state, a radioactive element slowly transforms. And somewhere in all of it, there is a hidden rhythm older than language, older than calendars, older than any creature that ever looked at the sky and wondered what a day was. Time, in human life, often feels personal. A waiting room stretches, a childhood summer expands, a beautiful hour disappears too quickly. But the universe does not need your feeling of time to measure change. It keeps its own clock through patterns that repeat, decay, vibrate, orbit, and evolve with remarkable consistency. The first clocks were not machines. They were shadows. A stick placed in sunlight could show the slow turning of Earth. The rising and setting of the sun divided life into day and night. The moon's changing face gave early humans a larger rhythm, a way to feel time in phases rather than hours. Seasons came from Earth's tilted axis and its yearly journey around the sun, turning time into harvest, cold, migration, and return. These were cosmic clocks written into survival, but they were not perfect. Earth's rotation is not absolutely steady. It wobbles slightly. It slows over long periods because the moon's gravity raises tides, and those tides gently drain rotational energy from the planet. A day in the distant past was shorter than a day now. Even the ground beneath ordinary time is not as fixed as it seems. So humans learn to look deeper for steadier rhythms. Mechanical clocks use swinging pendulums and turning gears. Quartz clocks use the steady vibration of crystals. Then atomic clocks changed everything. Instead of depending on a planet's spin, they depend on the natural behavior of atoms. The modern second is defined using a specific transition in cesium atoms, because atoms of the same kind behave identically everywhere under the same conditions. A cesium atom is not impressed by your schedule. It does not care about sunrise, empire, anxiety, or memory. It offers a rhythm so stable that it lets civilizations synchronize satellites, communication networks, scientific experiments, financial systems, and navigation across the planet. In a sense, our most precise clocks no longer ask Earth what time it is. They ask matter itself, and matter answers with vibration. But the universe keeps clocks on scales far beyond the human hand. Some stars act like celestial metronomes. Pulsars, the rapidly spinning remains of collapsed stars, can send beams of radiation into space with such regularity that astronomers once wondered whether they might be artificial signals. They are not alien lighthouses, but they are natural clocks of astonishing precision. Each pulse is the sweep of a stellar beam across our line of sight, like the flash from a lighthouse turning in the dark. Some pulsars are so stable that tiny changes in their timing can reveal hidden companions, gravitational effects, or ripples in space-time itself. Farther out, galaxies move, clusters drift, and the expansion of the universe becomes another kind of clock. The universe has been stretching since its earliest hot, dense state, and by studying that expansion, along with ancient light left over from the young cosmos, scientists can estimate cosmic age. This does not mean the universe has a clock hanging above it, ticking in empty space. It means the universe carries records of its own history in its structure, in the temperature of ancient radiation, in the chemical fingerprints of stars, in the distances between galaxies, in the proportions of hydrogen and helium, in the slow burning and death of suns. Every star is also a clock because stars change as they use their fuel. A young star, a red giant, a white dwarf, a supernova remnant. Each stage tells a story of time passing through matter. Even rocks keep time. Radioactive elements decay at known rates, allowing scientists to date ancient minerals, fossils, meteorites, and the Earth itself. A stone may look silent, but inside it, atoms have been transforming for millions or billions of years, leaving a record more patient than memory. This is one of the most beautiful truths in science. Time is not measured by clocks alone. Time is measured by change that can be trusted. If something repeats steadily, it can mark duration. If something decays predictably, it can mark age. If something evolves through known stages, it can reveal history. The universe keeps its own clock not in one place, but everywhere at once, in the turning of planets, the beating of pulsars, the cooling of ancient light, the aging of stars, the decay of atoms, and the motion of galaxies. And yet, there is something humbling here. Human time is urgent because human life is short. Cosmic time is patient because the universe has no heartbeat like yours. A mountain range can rise and erode while generations are born and forgotten. A star can burn for billions of years without noticing the civilizations that appear briefly around it. A galaxy can rotate while entire species come and go beneath a single sun. When you look at time this way, your own clock becomes smaller but not meaningless. Your pulse is also a rhythm. Your breathing is also a cycle. Your cells also repair, divide, age, and count the passing of life in chemical changes too quiet to hear. You are not separate from the universe's clocks. You are made of them. The calcium in your bones, the iron in your blood, the carbon in your cells, all of it came from cosmic processes that unfolded long before you existed. Your body is a temporary arrangement of ancient material, keeping time with biology for a little while, under a star that keeps time with nuclear fire, on a planet that keeps time by turning through darkness and light. So when you ask how the universe keeps its own clock, the answer is not one machine, one master rhythm, or one perfect cosmic bell. The answer is that the universe remembers through change. It counts through cycles. It marks age through transformation. It carries time not as a number written somewhere beyond the stars, but as a pattern woven into everything that moves, burns, cools, spins, decays, or returns. And for a brief moment, you are one of those patterns too, a living clock made of stardust, aware enough to hear the ticking. Why time had a beginning, or maybe didn't. The strangest thing about the beginning of time is that the word beginning may be the wrong tool for the job. You are used to beginnings. A song begins when the first note arrives. A day begins when morning light touches the window. A life begins with a first breath, a first cry, a body entering the world already moving toward age. So when you hear that the universe had a beginning, your mind naturally reaches for the same kind of image. A dark emptiness, a sudden spark, an explosion, and then time starting like a clock wound for the first time. But cosmology is quieter and stranger than that. The Big Bang was not an explosion inside empty space. It was the early universe itself, extremely hot, extremely dense, expanding and cooling from a state unlike anything familiar to human experience. When scientists traced the universe backward, galaxies were closer together, matter was hotter, light was more compressed, and the cosmos becomes harder and harder to describe with ordinary language. Keep going far enough backward using Einstein's theory of gravity, and the equations point toward a limit where density and temperature become extreme beyond meaning. This is often called the beginning. But in science, a limit like that does not always mean reality truly began there. Sometimes it means the theory you are using has reached the edge of where it can speak clearly. It is like following a map until the ink fades at the coastline. You have not necessarily reached the end of the world. You may have reached the end of the map. That is why physicists are careful. The evidence strongly tells us the universe was once much hotter, denser, and more compact than it is today. We see ancient light from the early cosmos, now stretched into a faint microwave glow across the sky. We see galaxies moving apart on large scales. We see the chemical fingerprints of a young universe that made mostly hydrogen and helium, before stars had time to forge heavier elements. These are not guesses. They are pillars of modern cosmology. But whether time itself began at that earliest boundary is a deeper question. If time began with the universe, then asking what happened before time may be like asking what is north of the North Pole. The question feels meaningful because grammar allows it, but the structure of reality may not. Before is a time word. It assumes a timeline already exists. If time itself came into existence with the Big Bang, then there may be no earlier moment in which something could happen. There would be no empty waiting room before creation. No cosmic silence counting down to the first second, because waiting and counting already require time. This idea can feel almost impossible to hold in the mind. You want a cause, you want a prior state, you want a first push. Human thought is built from everyday experience, where every event has something before it. A door opens because a hand turned the handle. Rain falls because clouds formed earlier. A tree grows because a seed was planted, but the universe as a whole may not behave like an object inside another larger room. If time is part of the universe, then the universe does not need to begin in time the way a fire begins in a forest. Time may be part of what begins, and yet this is not the only possibility. Some scientific models suggest that the Big Bang may not have been the absolute beginning, but a transition. Perhaps there was an earlier contracting phase, a kind of cosmic collapse that bounced into expansion. Perhaps our universe emerged from a quantum state where the usual idea of time was blurred or not yet classical. Perhaps time did not begin sharply, but gradually became meaningful as the universe cooled and took on the structure we recognize. Some approaches even suggest that what we call time may be emergent, not fundamental, a property that appears when deeper ingredients of reality interact in the right way. The way temperature appears from the motion of many particles, but is not something a single particle possesses by itself. These ideas are fascinating, but they are not final answers. This is where honesty matters. No one currently knows with certainty whether time had an absolute beginning. The earliest moments are hidden behind conditions where our best theories, general relativity and quantum physics, both matter deeply, but do not yet fit together completely. General relativity explains gravity and the large-scale shape of the universe with extraordinary success. Quantum physics explains the behavior of matter and energy at tiny scales with astonishing accuracy. But the very early universe demands both at once, and we do not yet have a complete, tested theory of quantum gravity. So the beginning of time remains a frontier, not a solved chapter. Still, the question itself teaches something powerful. It shows that time may not be the background of existence. It may be something woven into existence. It may have limits, phases, depths, or origins of its own. And if that is true, then the beginning of time is not like the start of a stopwatch. It is more like the appearance of a dimension in which change can be ordered, memory can form, causes can link to effects, and eventually stars, planets, chemistry, and conscious beings can ask where the ordering came from. There is a strange intimacy in that. Your own life depends on time, but time may not be a simple container holding your life. It may be a feature of the universe that became possible under certain physical conditions. You can measure seconds, mark birthdays, fear endings, and remember childhood. But beneath all of that is a deeper mystery. Why is there a sequence at all? Why is reality arranged so that one state gives way to another? Why does the cosmos allow history instead of timeless stillness? If time had a beginning, then every moment you have ever lived belongs to a story that started not merely with matter, but with the possibility of after. If time did not have a beginning, then existence may stretch deeper than our observable history. Through earlier phases or structures, our current science can only partially imagine. Either way, the answer is not small. It changes the meaning of origin. It asks you to see the universe not as a thing that simply appeared one day, but as a mystery in which day, appearance, and before may all be part of the thing needing explanation. And perhaps the gentlest truth is this: science has not removed wonder from the beginning. It has made the wonder more precise. It has shown us that the universe has a history, that its early fire left evidence, that space expanded, that ancient light still surrounds us, and that the question of time's first moment remains one of the deepest open doors in human thought. So when you think of the beginning, do not picture only a flash in darkness. Picture the edge of understanding itself, where language starts to fail, where clocks cannot be placed outside the cosmos to watch it begin, where the past may have a boundary or may curve into something stranger. And from that uncertain edge, every second of your life has somehow unfolded. Every breath, every loss, every morning, every memory, all carried by a dimension whose own origin may be as mysterious as existence itself. The mystery of what happened before the Big Bang. If you try to look before the Big Bang, you are not staring into darkness. You are staring into the place where the word before begins to lose its grip. The human mind wants a scene. It wants a stage before the first light. An empty space waiting quietly. A silence sitting there until the universe suddenly arrived. But that picture smuggles in something we may not be allowed to assume. Time already existing. Space already waiting. A then before the first now. In modern cosmology, the Big Bang does not simply mean that matter exploded into a pre-existing void. It means that the observable universe was once compressed into an extremely hot, dense state and has been expanding and cooling ever since. When scientists run the story backward, the universe becomes hotter, denser, and more extreme, until our current theories begin to strain. And there, at that ancient edge, the question, what happened before, becomes one of the most difficult questions a human being can ask, because it may be asking for an earlier chapter in a book whose pages may not exist in the usual way. One possibility is that there was no before in the ordinary sense. If time is part of the universe rather than a separate container around it, then the Big Bang may mark not just an early event in time, but the boundary where time as we understand it becomes meaningful. In that view, asking what came before the Big Bang is like asking what is earlier than time itself. The question feels natural because every event in your life has something before it. A footstep before a door opens, a spark before a fire spreads, a decision before a consequence. But the universe is not an object sitting inside a larger clock. It may be the system that gives clocks their meaning. Still, scientists do not simply stop there and declare the mystery solved. They explore many possible models, each one trying to reach behind the visible beginning without pretending certainty. Some ideas suggest that the Big Bang may have been a bounce. In these models, the universe might have gone through an earlier phase of contraction, shrinking under its own dynamics until quantum effects or some unknown physics prevented a true collapse, causing expansion to begin again. If that is true, then our Big Bang was not the absolute birth of everything, but a turning point, like a cosmic breath-changing direction. Other ideas imagine a cyclic universe where expansion and contraction repeat across vast timescales, each cycle leaving only faint clues, if any, for the next. There are also proposals connected to cosmic inflation. The idea that the very early universe underwent a brief, extraordinary expansion. Some versions of inflation suggest that our universe may be one bubble in a much larger inflating reality, where other regions could exist beyond what we can ever observe. This does not mean scientists have proven a multiverse. It means some mathematical models allow such a possibility, and the challenge is finding evidence strong enough to separate imagination from physics. There are even stranger proposals, like the idea that the universe could emerge from a quantum state where ordinary time does not behave the way it does now, or that the beginning could be smooth and boundaryless, more like the surface of Earth having no sharp edge, even though it is finite in extent. These ideas are not casual fantasies. They come from serious attempts to combine gravity, quantum physics, and cosmology, but they remain uncertain because the earliest era of the universe is hidden behind energies and conditions we cannot directly recreate, and behind distances so vast that light itself limits what we can know. The universe gives us evidence, but not unlimited access. We can observe ancient radiation, the spread of galaxies, the chemical remains of the early cosmos, and the large-scale structure carved into space. These are like ashes, footprints, and fingerprints from an unimaginably old fire. They tell us much about what happened after the universe became observable in a physical sense. But the closer we move toward the first fraction of a second, the more our knowledge becomes a careful combination of tested physics, mathematical extension, and honest uncertainty. This is where the mystery becomes beautiful rather than empty. Science does not say, "We know nothing." It says, "We know the universe had an early hot, dense phase. We know it expanded. We know its early conditions shaped everything we see, but we do not yet know whether that phase was the absolute beginning or the aftermath of something deeper." That distinction matters. It keeps wonder disciplined. It protects the truth from becoming a story told too confidently. When people say, "before the Big Bang," they may be pointing towards several different questions at once. Was there an earlier universe? Was there a deeper law from which our universe emerged? Did time begin, or did time change form? Did cause and effect exist in any recognizable way before the first moments we can describe? Each question touches the edge of language, because cause usually means one thing happening before another. But if time itself is under question, even the idea of a cause becomes slippery, and yet your mind keeps reaching. It wants an origin behind the origin, a reason behind the reason, a door behind the door. Maybe that desire is not a weakness. Maybe it is what consciousness does when it meets a horizon. It cannot see beyond, so it learns to name the horizon carefully. The mystery of what happened before the Big Bang is not a simple blank. It is a boundary between what evidence has shown and what theory is still trying to understand. Perhaps there was no before. Perhaps there was a bounce, a cycle, a quantum beginning, or a deeper reality whose structure has not yet entered human science. We do not know, but even that uncertainty teaches something profound. The universe may not owe us a beginning shaped like human memory. It may not begin the way a story begins. It may not have waited in darkness. It may be stranger than emptiness, older than before, and more subtle than any image your mind can hold. And still, from whatever that hidden edge was, everything familiar eventually unfolded: stars, atoms, oceans, breath, thought, and this quiet question inside you, reaching back toward a moment that may not have been a moment at all. Why some stars you see are already dead. Some lights in the night sky may be messages from stars that no longer exist in the form your eyes are seeing. You look up and feel as if the sky is present, as if every point of light is burning right now, above you in the same shared moment. But the night sky is not a live image of the universe. It is an archive. Every star you see is separated from you by distance, and distance turns light into a messenger that arrives late. A star does not send its brightness to your eyes instantly. Its light must cross space, year after year, sometimes for decades, sometimes for centuries, sometimes for thousands of years before it reaches Earth. So when you see a star tonight, you are not seeing the star exactly as it is at this moment. You are seeing it as it was when that light began its journey. If a star is 100 light years away, the light entering your eye tonight left that star 100 years ago. If it is 1,000 light years away, you are seeing a version of it from 1,000 years in the past. This means the sky above you is layered with different ages. One star may be showing you the universe from before you were born. Another may be showing you light that began traveling before your grandparents were alive. Another may be carrying a glow that started its journey when ancient civilizations were still building temples, writing myths, and reading the same sky with completely different names for the same lights. But here is the important truth. It would be misleading to say that most of the stars you see with your naked eye are already dead. Many of the visible stars are relatively close by cosmic standards, and many stars live for millions, billions, or even trillions of years depending on their mass. Small red dwarf stars can last far longer than the current age of the universe. Stars like the Sun live for billions of years, so if you see an ordinary nearby star, it is probably still shining. The haunting possibility belongs mostly to certain kinds of stars, massive, unstable stars that burn through their fuel quickly, and distant stars whose light has taken so long to reach us that their current state may have changed beyond recognition. Massive stars are the bright, dramatic lives of the cosmos. They are born with enormous weight, burn fiercely, fuse heavier elements in their cores, and spend their fuel at a speed that smaller stars do not. Their lives can be short in cosmic terms, sometimes only a few million years, which is almost nothing compared with the long, quiet lifespan of a smaller star. When a massive star reaches the end of its fuel, it can collapse and explode as a supernova, briefly shining with such power that it can outshine an entire galaxy. What remains may become a neutron star, a black hole, or a spreading cloud of enriched material that later helps form new stars and planets. So when you look at a bright, massive star far away, there is a real possibility that the light you see belongs to a stage of life that has already ended. The star may have changed. It may have expanded, collapsed, exploded, or vanished behind a remnant too dark for your eyes to see. One famous example is Betelgeuse, the red supergiant in Orion. It is not known to have exploded, and scientists do not claim it already has. But because it is hundreds of light years away and near the later stages of its life, the version you see is delayed. If it were to explode tonight from our point of view, that would mean the actual event happened centuries ago, and the light had only now reached us. If it has not exploded, it may do so sometime in the future, perhaps in thousands or tens of thousands of years. The uncertainty is part of the wonder. A star can be physically doomed long before the universe sends you the final announcement. Space does not deliver death instantly. It delivers it at the speed of light. And this turns astronomy into a kind of time archaeology. Telescopes are not only magnifying glasses, they are time machines without engines. When astronomers look at distant galaxies, they are not seeing them as they are now, but as they were when their light left. Some galaxies are seen billions of years in the past. When the universe was younger, galaxies were more turbulent, and stars were forming in different cosmic conditions. In those distant galaxies, Countless individual stars that contributed to the light we see are certainly gone now. Their light remains, but their lives have ended. The universe allows this strange separation between presence and existence. A thing can still be visible after it has changed or died, because visibility depends not on what is happening now, but on what information has reached you. A star's light can outlive the star you are seeing, the way a voice can echo through a canyon after the speaker has gone silent. But unlike an echo that fades in seconds, starlight can travel for ages, crossing emptiness with almost no resistance, carrying color, temperature, motion, and chemical clues across unimaginable distances. In that light, scientists can read what a star was made of, how hot it was, whether it was moving toward or away from us, and sometimes what stage of life it had entered when the light began its journey. The sky is not just beautiful, it is informational. Every point of light is a report, and every report is late. This also changes the emotional meaning of looking upward. The night sky can feel eternal, but it is not a fixed ceiling. It is a moving record of births, aging, explosions, and disappearances. Some stars you see may still be calmly burning. Some may be changing in ways you will never witness. Some distant sources of light may be ancient signals from objects transformed beyond recognition. And some stars that exist right now will not be visible to future eyes because their final light has not yet arrived, or because it will arrive long after human memory has changed shape. You are not looking at a single cosmic present. You are looking at many pasts arranged together on one dark surface, as if the universe has placed different centuries beside each other and called it a sky. This does not make the stars less real. It makes them more profound. Their beauty is not only in their brightness, but in the distance their brightness has survived. When a star dies, the universe does not erase it immediately from our view. It lets the last chapters travel outward, crossing space long after the physical event has passed. And maybe that is why the thought feels so quietly human. Much of what shapes you also arrives late. You understand people after they leave. You feel the meaning of a moment after it has ended. You carry the light of things that are no longer here in the same form. The stars teach this without speaking, that what is gone may still be arriving, that endings can take time to reach the heart, and that the sky above you is not only a place of shining objects, but a library of delayed goodbyes. So tonight, if you look up and see a star, do not assume you are seeing a simple dot in the present. You may be seeing an ancient message still traveling faithfully through the dark, a piece of stellar history touching your eyes long after it began, reminding you that the universe is so vast that even death can glow before it finally disappears. How looking into space means looking back in time. Every telescope is secretly aimed at history, not distance. When you lift your eyes toward the sky, it feels as if you are looking outward, across emptiness, toward places that exist somewhere far away. But space has a strange condition built into it. The farther away something is, the older the version of it you are allowed to see. Distance and time are tied together by light. Light is fast beyond ordinary imagination, fast enough to circle Earth many times in a single second, but it is not infinitely fast. It still needs time to travel. That means the universe never shows itself all at once. It arrives in layers. Nearby things send you recent news. Farther things send you older news. The deepest objects send messages that began traveling when the universe itself was younger. Before Earth existed, before the sun existed, before the ingredients of your body had gathered into a planet, a nervous system, and a mind capable of asking where the light came from. This is why looking into space means looking back in time. Astronomy is not just the study of distant objects, it is the study of delayed light. A telescope does not pull galaxies closer in the way a hand pulls a book from a shelf. It collects faint, ancient photons that have crossed the universe for millions or billions of years and lets them become information. In that sense, a telescope is less like a window and more like an archaeological instrument made of glass, mirrors, and patience. It does not dig into soil. It digs into time. When astronomers observe a galaxy billions of light years away, they are not seeing that galaxy as it is now. They are seeing it as it was billions of years ago, when its light began the long journey toward us. The galaxy may have changed completely since then. It may have merged with another galaxy, formed new generations of stars, quieted down, grown heavier, lost gas, changed shape, or drifted into a structure we cannot yet see because its more recent light has not reached us. This is one of the most important ideas in cosmology. The universe is not presented to us as a single present tense picture. It is presented as a stack of eras, with older and older scenes appearing the farther we look. The sky is not flat in time, it has depth, and that depth allows scientists to study cosmic evolution, almost the way a biologist might study living creatures at different stages of life. If you want to understand how galaxies grow, you cannot wait billions of years and watch one galaxy from birth to maturity. Human lives are too short. Civilizations are too short. Even recorded history is almost nothing compared with galactic time. But because light takes time to travel, the universe gives us a different method. Look nearby and you see galaxies in a relatively recent stage. Look farther away and you see galaxies as they were when the cosmos was younger. Look farther still and you see smaller, rougher, more chaotic systems from earlier cosmic ages. It is like walking through a museum where every room contains a different century, except the museum is the universe itself, and the exhibits are real galaxies caught in the age their light departed. This is how astronomers learn that galaxies did not always look the way they do now. The early universe contained clouds of gas, young stars, growing black holes, and galaxies still assembling themselves through collisions and gravitational attraction. The grand spiral galaxies and large elliptical galaxies we see closer to home are not timeless forms placed into space fully finished. They are outcomes of long histories. Their shapes carry memory. Their stars carry chemical records. Their colors tell us something about age, temperature, and star formation. Blue light often suggests young, hot stars being born in active regions. Redder light can indicate older stellar populations or light stretched by the expansion of space. And that stretching, called redshift, is one of the key tools for reading cosmic time. As the universe expands, light traveling through it is stretched to longer wavelengths. The farther a galaxy is, generally, the more its light has been stretched during its journey. This does not mean the light became tired in a simple way. It means space itself expanded while the light was moving through it, lengthening the waves. By measuring that stretching, astronomers can estimate how long the light has been traveling and how far back in cosmic history they are looking. The universe, in this way, writes time into color. A faint red point in a deep image may not simply be a dim object. It may be a young galaxy whose light has been stretched across billions of years of expansion before arriving at our instruments. And the farther we look, the more difficult the seeing becomes. Ancient light is faint because it has spread out across enormous distances. It is stretched, weakened, and often shifted into forms of light that human eyes cannot see. That is why modern observatories use instruments sensitive to infrared, radio waves, X-rays, and other parts of the spectrum. Human vision is only a narrow doorway. The universe speaks in many kinds of light, and each kind carries a different part of the story. Infrared light can pass through dust that blocks visible light, revealing young stars forming inside cloudy regions. Radio waves can show cold gas, magnetic fields, and ancient radiation. X-rays can reveal violent places around black holes, neutron stars, and hot gas in galaxy clusters. To look back in time, scientists must learn the full language of light, because the early universe does not always speak in the colors our eyes were made to understand. The deepest look back of all comes from the cosmic microwave background, the leftover glow from when the universe first became transparent enough for light to travel freely. Before that era, the universe was filled with hot, dense plasma, where light constantly scattered and could not move far in a straight line. Then, as the universe expanded and cooled, electrons and nuclei combined into neutral atoms, and light was released to travel across space. That ancient glow still surrounds us from every direction, stretched by cosmic expansion into microwave radiation. It is not a picture of the Big Bang itself, but it is one of the oldest light signals we can observe. It shows the universe as it was when it was only about 380,000 years old, incredibly young compared with its current age. In that faint pattern are tiny temperature differences, seeds of later structure, clues to how matter would gather into galaxies, stars, planets, and eventually the conditions for life. This is where looking into space becomes almost impossible to separate from looking into origin. You are not just seeing objects far away. You are seeing earlier versions of reality when the universe had not yet made most of what you know. No Earth, no oceans, no bones, no trees, no human names for anything. Just patterns of matter and radiation beginning the long work of becoming structure. And yet there is a limit. We cannot see with light beyond the point where the universe was opaque, because earlier light could not travel freely to us. To learn about times before that, scientists must use indirect evidence, mathematics, particle physics, gravitational waves if they can be detected from early enough eras, and careful models that connect present observations to ancient conditions. The universe reveals a great deal, but not everything. Its history is visible only where messengers can reach us. This is a humbling truth. You cannot simply demand the universe show you its full past. You can only read the messages that survived the journey, and every message arrives changed by the path it took. Light may be bent by gravity, stretched by expansion, absorbed by dust, or mixed with other signals. Astronomy is therefore not passive looking. It is interpretation. It is learning how to separate what the object was from what the journey did to its light. And still, despite all this difficulty, the result is extraordinary. From a small planet around an ordinary star, human beings have learned to reconstruct billions of years of cosmic history from faint signals falling onto mirrors and detectors. We can look at a patch of sky that seems empty, and with enough exposure, reveal thousands of galaxies, each one a chapter from a different depth of time. We can see that the universe was once smoother, hotter, denser, and younger. We can watch galaxies change across cosmic ages. We can detect ancient light older than any star. And perhaps the strangest part is that all of this happens from the present moment of your awareness. You sit here now, but your instruments can receive light from then. The mind lives in the present, but the eye can be touched by the past. That gives the night sky a deeper emotional shape. It is not only beautiful because it is vast, it is beautiful because it is delayed. It teaches you that reality does not arrive all at once, that understanding depends on patience, that what is far away may also be long ago, and maybe your own life has a small echo of this cosmic truth. You often understand things late. The meaning of a moment may reach you long after the moment itself has passed. A lesson may travel through years before it finally arrives inside you. A person's influence may continue long after they are gone. The universe works this way on an unimaginable scale. It lets old light keep moving. It lets history remain visible if you know how to look. So when you look into space, you are not escaping time. You are entering it more deeply. You are watching distance turn into memory, light become evidence, and darkness reveal that the past is not simply behind you. It is still arriving, softly from every direction. Why time moves slower? Near a black hole. A black hole does not merely pull matter inward, it pulls the very pace of time towards silence. Far from a black hole, a clock can tick in a familiar rhythm, steady and ordinary, the kind of rhythm you trust without thinking. But bring that clock closer to the black hole's edge, closer to the region where gravity becomes extreme, and something deeply strange begins to happen. Compared with a clock far away, it slows down. Not because the clock is broken, not because its gears are tired or its atoms are confused. It slows because time itself is being shaped by gravity. A black hole is not just a dark object in space. It is a place where mass has been compressed so intensely that space-time curves into an almost unimaginable depth. Around every massive object, time is affected, but near a black hole the effect becomes dramatic. The closer you get to the event horizon, the boundary beyond which nothing can escape back out, not even light, the more your time appears to slow from the viewpoint of someone watching safely from far away. If you carried a clock toward that boundary, you would not feel your own time suddenly becoming sluggish. Your thoughts would still feel normal to you. Your heartbeat would feel like your heartbeat. The ticking beside you would seem ordinary from your own perspective. That is one of the most important truths. Time always feels normal locally. The weirdness appears when two observers compare their realities. Someone far away, watching you approach the black hole through a powerful telescope, would see your clock ticking more and more slowly. Your movements would appear to stretch out. Your signals would arrive weaker, redder, and more delayed, because the light escaping from near the black hole has to climb out of an extreme gravitational well. As that light struggles outward, it loses energy and shifts toward longer, redder wavelengths. This is called gravitational redshift, and near a black hole it becomes severe. To the distant watcher, you would seem to slow down as you approach the horizon, fading and reddening, almost as if time were turning you into a ghost at the edge of darkness. But from your own falling perspective, you would cross the event horizon in a finite amount of time, assuming the black hole were large enough that tidal forces did not destroy you first. You would not see a glowing sign saying boundary crossed. The event horizon is not a solid surface. It is not a wall you crash into. It is a point of no return in the structure of space-time itself. Once you pass it, all possible future paths lead deeper inward. Escaping would no longer be a matter of having a stronger rocket. It would be like trying to move into yesterday. The geometry has changed the meaning of direction. This is why black holes are not simply objects with strong gravity. They are regions where the future tilts inward. Outside the horizon, you can still choose paths that lead away. Inside, every path points toward the singularity or whatever deeper structure future physics may eventually describe more accurately. The slowing of time near a black hole is therefore not a magical freezing spell. It is a consequence of relativity, of the way mass and energy shape space-time and the way clocks follow that shape. If you hover near a black hole instead of falling freely, you would need enormous acceleration to resist being pulled inward. And the closer you try to hover to the horizon, the more extreme that effort becomes. For a distant observer, a clock held very close to the horizon would run incredibly slowly. In theory, as it approached the horizon, its ticking would appear to slow without ever quite completing the crossing in the distant observer's view. But this does not mean the falling object itself never crosses. It means the light carrying the information outward becomes more delayed and stretched until the image becomes practically invisible. This difference between what the distant watcher sees and what the falling traveler experiences is one of the most beautiful and unsettling lessons of relativity. Reality is not always described by one universal viewpoint. The event can be real in both descriptions, even when the descriptions feel impossible to reconcile in everyday language. Near a black hole, the universe forces you to give up the idea that time is a single shared stage where all observers agree on what is happening moment by moment. Instead, time becomes linked to position, motion, and the depth of gravity. This has real consequences beyond imagination. Around black holes, gas can spiral in a disk, heating to extreme temperatures before falling inward. Light from that disk can be bent by gravity, looped, distorted, and magnified, creating strange rings and arcs. If you could safely watch from outside, you would see not just matter moving through space, but time being sculpted into the image. Some light reaches you directly. Some light has taken a curved path around the black hole. Some comes from material moving so fast that one side appears brighter than the other. Even the famous shadow of a black hole is not a simple photograph of a surface, because there is no surface to photograph. It is a portrait of paths light can and cannot take, a map of gravity's influence on visibility itself. And hidden in that image is the same truth. Where gravity is extreme, time is extreme too. For smaller black holes, the danger near the horizon can be violent because gravity changes sharply over short distances. The pull on your feet could be much stronger than the pull on your head, stretching matter in a process often called spaghettification. For supermassive black holes, the event horizon can be so large that the tidal forces at the boundary might be weaker, allowing a falling observer to cross without immediate destruction. though the deeper journey would still end disastrously. This distinction matters because black holes are not all the same. Some form from collapsed massive stars. Others sit in the centers of galaxies with millions or billions of times the mass of the Sun. Their gravity shapes surrounding stars, gas, and light. But their time-warping power near the horizon follows the same deeper principle. The stronger the gravitational field, the more severely time differs between observers at different distances. And perhaps this is why black holes feel so haunting. They do not only represent darkness, they represent a place where the ordinary agreements of life fail. Here on Earth, you and another person can disagree about feelings, memories, meanings, but you usually trust that a second is a second. Near a black hole, even that quiet trust breaks open. One person's brief fall can become, to a distant universe, an image stretched toward eternity. One clock can remain loyal to itself, while another far away tells a different story. Time does not disappear, it becomes deeply relational. It belongs to the path you take through the curved architecture of reality. This does not make black holes supernatural. It makes them more extraordinary than myth, because they are real objects predicted by theory, observed through their effects, and now imaged through the light around them. They teach that time is not a rigid ruler laid across the cosmos. It is flexible, local, and vulnerable to gravity's deepest wells. So when you imagine a black hole, do not picture only a cosmic drain swallowing stars. Picture a place where clocks lose agreement, where light climbs out exhausted, where distance watchers see motion slow and fade, and where the future itself bends inward. Near a black hole, time moves slower not because the universe forgets how to tick, but because gravity has changed what ticking means. And in that dark lesson there is a strange softness. The seconds you live are not floating above the universe. They are woven into it, shaped by matter, curved by mass, and held, even here, by the same laws that make the edge of a black hole feel like the border between time and forever. Why time might end in the far future. The last second of the universe may not arrive with an explosion, but with the disappearance of anything left to count it. When people imagine the end of time, they often picture a final catastrophe. Stars tearing apart, space cracking open, a cosmic clock striking its last note. But the far future may be far quieter than that. Time might not end because a wall appears at the edge of reality. It might end because change slowly loses its ability to make a difference. A clock only works if something happens in a repeatable way. An atom vibrates, a planet turns, a star burns, a heart beats, a machine cycles, a thought moves from one state to another. But in the deepest future suggested by modern cosmology, the universe may become colder, darker, emptier, and more evenly spread out, until meaningful processes become rare beyond imagination. Today, the universe is still alive with contrast. Stars shine because hot cores pour energy into colder space. Planets exist because matter clumped together. Life exists because energy flows through fragile systems, building temporary order while releasing heat. Every event depends on difference: hot and cold, dense and empty, light and dark, motion and rest before and after. But if the universe keeps expanding, and especially if dark energy continues to drive that expansion faster and faster across cosmic distances, the far future becomes a place where contrast fades. Galaxies beyond our local group will slip beyond reach, not because they move through space faster than light in a local sense, but because space between cosmic regions stretches so much that their light may never reach future observers. The night sky of an unimaginably distant future would not be crowded with galaxies. It would be mostly empty, because the universe's expansion would have carried the evidence of distant structure away. Long before that final dimness, stars would stop forming. Stars are born from cold gas clouds, but gas is not unlimited. Over enormous timescales, it is used up, locked into remnants, blown away, or heated until new star formation becomes harder and harder. The bright age of the cosmos, the age of stars, will not last forever. Massive stars die quickly. Sun-like stars fade into white dwarfs. Smaller red dwarfs can burn for trillions of years, far longer than the current age of the universe. But even they are not eternal. Eventually, the last stars will cool, the last stellar embers will fade, and the universe will enter an age dominated by remnants. White dwarfs gone dark, neutron stars, black holes, frozen planets, and scattered matter drifting through a growing darkness. This is not something to fear in a human sense, because it lies so far beyond ordinary time that your mind cannot truly hold the scale. But it teaches something profound. The universe is not guaranteed to remain dramatic. It may spend most of its existence not in fire, but in quiet aftermath. Black holes, which seem like final objects, may also not be eternal if Hawking radiation is correct. According to that idea, black holes can slowly lose energy through quantum effects near their horizons, shrinking over timescales so vast that the numbers almost stop feeling like time at all. Small black holes would evaporate sooner. Supermassive ones would endure for periods beyond imagination. But in the distant future, even black holes may fade away, releasing their remaining energy as thin radiation into a universe already stretched and cold. After that, what remains? Perhaps particles, radiation, dark matter if it persists, faint fields, and space expanding into deeper isolation. If protons eventually decay, a possibility not yet confirmed, ordinary matter itself may slowly disassemble. If they do not decay, matter may remain in extremely cold, sparse forms for even longer. Scientists do not know every detail because the far future depends on physics we have not fully tested. The true nature of dark energy, whether protons decay, how quantum gravity works, whether the vacuum of space is perfectly stable, and whether new physics changes the ending. So the honest answer is not that time definitely ends. It is that one possible far future makes time lose its practical meaning. If nothing changes in a way that can be measured, if no clocks can tick, if no structures remain to remember, compare, or transform, then time may still exist in equations, but it would no longer feel like a story. It would be a dimension with almost no events to mark it. This is the strange difference between time as a feature of reality and time as something experienced through change. A perfectly empty, unchanging universe could have duration in a mathematical sense, but without events, what would duration mean? If there is no sunrise, no vibration, no decay, no thought, no movement that matters, then there is no natural rhythm left to separate one moment from another. Time would not end like a road cut off by a cliff. It would thin out like a sound fading into a room so large that the echo never returns. This idea is sometimes connected to heat death, the state where the universe approaches maximum entropy. Energy becomes so evenly spread and so unavailable for useful work that organized processes can no longer continue. Heat death sounds fiery, but it is almost the opposite. It is not burning, it is exhaustion. It is the universe running out of usable differences. A fire burns because there is fuel, oxygen, and a temperature difference. A living cell works because energy flows through it. A civilization exists because it can harvest gradients, sunlight, chemistry, motion, stored energy. Remove all gradients, and the machinery of becoming falls silent. The future may not be an enemy that attacks the universe. It may be a stillness that arrives when all the great imbalances have been spent. And yet, there is a deep caution here. The far future is not fully known. Some models imagine a big rip, where dark energy grows stronger over time and eventually tears apart galaxies, stars, planets, and perhaps even atoms. Others imagine a vacuum decay event, where the state of space itself changes, rewriting physics at the speed of light. These are speculative possibilities, not established destinies. The most widely discussed ending, based on current observations of accelerated expansion, is a long cooling into darkness and high entropy. But science does not pretend to see eternity with perfect eyes. It follows evidence, builds models, and keeps the door open where uncertainty remains. That uncertainty makes the question more honest, not less powerful. Because whether time literally ends, fades in meaning, or continues through an almost eventless future, the lesson is the same. Time depends on change to become visible. You know time because things happen. A star ignites, a shadow moves, a body ages, a memory forms, a voice says something it cannot take back. A universe with no meaningful change would be time without a witness, without a clock, without a before that differs from after. And that makes the present cosmos feel suddenly rare. We live not in the universe's final silence, but in its bright middle chapters, when stars still burn, planets still turn, chemistry still experiments, and awareness briefly rises from matter to ask how long the story can continue. The far future may be unimaginably dark, but you are not there. You are here, inside the era of contrast, where energy still flows, where clocks still tick, where one moment can still become different from the last. Maybe time might end someday, not as a cosmic scream, but as the fading of change itself. And maybe that is why this moment, with all its motion and uncertainty, is so quietly extraordinary. It can still happen. The strange future, where nothing changes anymore. The most unsettling future is not one where the universe is destroyed, but one where it survives so completely that almost nothing meaningful is left to happen. That is the strange future where nothing changes anymore, not because every particle has frozen into absolute stillness, and not because space has turned into a solid dead object, but because the universe may eventually lose the differences that make change useful, visible, and memorable. In ordinary life, change depends on imbalance. A storm forms because air masses differ. A flame burns because fuel can release stored energy. A body moves because muscles convert chemical energy into motion. A thought appears because electrical and chemical patterns shift inside the brain. Even a clock needs something to cycle, something to mark one state as different from the next. But if you take the universe far enough into the future, under the most widely discussed long-term picture, these imbalances fade. The cosmos keeps expanding, matter becomes more scattered, energy becomes more diluted, hot places cool, bright places dim. The differences that once powered stars, planets, chemistry, and life become harder and harder to find. The result is not a dramatic final scene, but a kind of cosmic leveling, where the universe approaches a state close to equilibrium. Equilibrium does not mean there is literally nothing in it. It means there is no longer much available contrast to drive large, organized processes. Think of a cup of hot tea placed in a cold room. At first, there is a clear difference between the tea and the air, so heat flows outward. You can feel the change. The tea cools. The room warms by a tiny amount. But after enough time, when everything has nearly the same temperature, the flow no longer has a useful direction. Molecules are still moving, but the obvious story is over. Nothing dramatic announces the ending. The system has simply run out of difference. The far future of the universe may be something like that, but on a scale so vast that the comparison almost breaks. Not a room, but all space. Not minutes, but ages beyond ordinary imagination. In such a future, nothing changes does not mean every microscopic event stops. Quantum fields may still fluctuate. Particles may still exist, depending on what physics ultimately permits. Space may still expand, but the kind of change that builds stars, warms worlds, forms complex chemistry, and gives rise to observers may become so rare that the universe is effectively quiet. This distinction matters. A universe can have tiny random motions and still be dead in the deeper sense that no lasting structure, no memory, no organized process, and no new complexity can easily arise. Change is not only movement. Change, in the sense that matters to life and history, requires direction, usable energy, and the ability for one state to become another in a way that leaves consequences. If everything becomes too evenly spread, consequences lose their sharpness. A mark cannot be made without a contrast between marked and unmarked. A machine cannot run without a source of energy and a place for waste heat to go. A mind cannot think without physical processes that consume energy and distinguish one pattern from another. A civilization cannot exist if there are no gradients left to harvest. This is why the far future can be described as a world where events become thin. There may be time, but almost no story. There may be space, but almost no stage. There may be existence, but almost no drama. And in that idea, the word nothing becomes more subtle than emptiness. It means the absence of difference, the absence of usable possibility, the absence of new arrangements that can grow into something rich. Modern physics does not claim we know every detail of this ending. The long-term fate of the universe depends on deep questions. Whether dark energy remains constant, whether matter is ultimately stable, whether black holes fully evaporate, whether the vacuum of space is stable forever, and whether unknown physics changes the picture. But if the universe continues on a path toward greater dilution and greater equilibrium, then the far future may be dominated by a silence that is not empty, but finished. One of the strangest ideas connected to this is that time itself may become difficult to notice when nothing large-scale changes. A clock needs a repeating process. A memory needs a physical record. A before and after needs states that can be compared. If there are no observers, no working clocks, no stable systems recording differences, then time may still exist in the laws of physics, but it would have almost no witness. There would be no sunrise to divide darkness, no orbit around a warm star, no living body aging under light, no eye receiving ancient photons and turning them into wonder. The universe would not need to end in order to become unreadable. It would only need to lose the patterns that make reading possible. This is why the future where nothing changes anymore feels more haunting than destruction. Destruction is an event. Stillness is the disappearance of events. A supernova at least has brightness, violence, transformation. A collision has sound in the imagination, force, before and after. But equilibrium is quieter. It is the slow removal of reasons for anything to become anything else. And yet, even this bleak possibility teaches something valuable about the present universe. We live in an era where change is still abundant. Stars are still forging elements. Planets still orbit in pools of light. Ice melts. Oceans circulate. Winds rise. Cells divide. Brains dream. And every moment is full of differences that have not yet been smoothed away. You live in a universe that still has gradients. Warm sunlight against cold space. Chemical energy inside food. Electrical tension inside nerves. Emotional tension inside memory and desire. Your life is possible because the cosmos has not reached stillness. You are not just alive in time. You are alive because time still has work to do. The far future reveals the present as a rare interval of unfinishedness. Everything you know depends on the universe not yet being at rest. A child learning a word, a forest growing after rain, a star forming in a cloud, a person changing their mind. Each of these is a small rebellion against sameness, not in defiance of physics, but because physics still allows pockets of order to rise while the larger universe moves toward balance. This makes change feel more sacred, not less. It means every meaningful transformation is temporary, local, and physically precious. The future where nothing changes anymore is not waiting nearby. It is unimaginably distant, and it may not unfold exactly as current models suggest. But as an idea, it places a mirror in front of your life. It asks what it means to exist during the age when things can still happen. It asks why you spend so many moments wishing time would pause, when the ability for moments to differ from one another is the very condition that lets anything matter. Perfect stillness sounds peaceful until you realize that peace without change cannot be experienced, remembered, or loved. To feel peace, something must be alive enough to feel it. To know beauty, there must be contrast. To become someone, you must pass through states that are not the same. And perhaps this is the soft truth hidden inside the universe's farthest silence. Change is not the enemy of meaning. Change is the doorway through which meaning enters. In the strange future where nothing changes anymore, the universe may remain, but the music may have faded into a note too even to hear. Here now, the note is still moving. That is why your breath matters. That is why a single thought can still become a choice. That is why this brief, restless, unfinished age of the cosmos is not merely a step towards silence, but the luminous interval in which silence has not yet won. Why time feels different in dreams. A dream can make 5 impossible hours feel like they happened inside a few minutes of sleep. And the strangest part is that your mind usually accepts the distortion without protest. You may run through a city you have never visited, speak with someone who has been gone for years, escape a danger that changes shape, return to a childhood room, fall through darkness, wake up suddenly, and feel as if an entire private lifetime has passed behind your closed eyes. Then you look at the clock and discover that only a short part of the night has moved. This is not because dreams are fake in the simple sense. While you dream, the brain is genuinely active. It is creating images, sounds, movement, emotion, memory fragments, and a sense of being somewhere. But the brain is not building dream time the same way it builds waking time. In waking life, your sense of time is supported by external anchors. Light changing through the day, sounds arriving from the environment, the movement of your body, conversations that follow rules, clocks on walls, tasks that begin and end, the resistance of the physical world. A waking hour has structure because the outside world keeps pushing back. In dreams, much of that structure is loosened. Your body is mostly still, especially during REM sleep, the stage strongly associated with vivid dreaming. Your eyes move beneath closed lids, your breathing changes, your brain becomes active in intense and unusual ways. But the ordinary world is largely cut off. Instead of building time from stable outside events, the dreaming brain builds time from emotion, memory, and narrative momentum. It does not need a hallway to remain the same length. It does not need a door to lead to the same room twice. It does not need a conversation to follow logic. One scene can become another without the slow physical steps that waking life demands. You can be in a house, then instantly on a train, then suddenly underwater, and the dream may offer no explanation because the sleeping brain is not primarily concerned with consistency. It is concerned with experience. This is one reason dream time feels strange. Dreams often skip the boring connective tissue of reality. They do not always show you walking down every street, opening every door, waiting through every pause. They jump to the emotionally important part, the fear, the reunion, the chase, the discovery, the moment of falling, the impossible face turning toward you. Your mind later stitches these moments into a story, and the story can feel longer than the actual sequence of dream events. In this way, dream time can feel expanded not because the brain literally lived every second of that imagined world, but because it created the impression of duration through meaning. A dream can suggest a long journey with a single image of arrival. It can imply years of knowing someone with one feeling of familiarity. It can make you believe there was a full history behind a place you only occupied for seconds. The brain is extraordinarily good at generating context. It can give you the feeling that something has always been true inside the dream, even if that always was invented at the moment you noticed it. During REM sleep, areas involved in emotion, visual imagination, and memory can be highly active, while parts of the prefrontal cortex involved in careful reasoning, self-monitoring, and reality checking may be less engaged than in waking life. This matters because the part of you that normally asks, "Does this make sense?" is not always fully awake. That is why dream time can bend without being questioned. You do not stop and say, "How did night become morning in 1 second?" Or, "Why am I suddenly older?" Or, "How did I know this person for years when I just met them?" The dream gives you a feeling, and the feeling becomes accepted as fact. Time in dreams is often emotional time. Fear can make a few moments feel enormous. Longing can make a brief encounter feel eternal. Confusion can stretch a simple scene into a maze. Joy can vanish so quickly that waking feels like losing something before you ever held it. But science also keeps this mystery grounded. Not every dream happens in an instant. Some studies of lucid dreamers, people who know they are dreaming while the dream is happening, suggest that certain timed actions in dreams can take roughly similar amounts of time to waking actions, though often with differences depending on the task and sleep state. So it would be false to say dreams always compress hours into seconds. The truth is more interesting. Dream time is flexible. Some dream actions may unfold in a way that roughly tracks real time, while dream narratives can still feel much longer because the brain adds background, implication, skip transitions, and emotional density. A dream is not a stopwatch. It is a theater where scenes can be rearranged, shortened, expanded, or connected by feeling rather than physics. Another reason dreams distort time is that memory after waking is fragile. When you wake up, you are not always retrieving a clean recording of the dream. You are reconstructing it from fragments before they fade. The brain may organize those fragments into a sequence that feels complete, even though the original dream may have been discontinuous. You might remember the chase, then the conversation, then the strange room, and assume they happened as one long chain. But the sleeping mind may have moved through them in a looser way, with gaps you never noticed. Waking memory fills in the dream's missing bridges. It gives the dream a timeline because the waking mind prefers stories with order. This is why a dream can feel detailed and yet become difficult to explain. It had its own logic while you were inside it, but that logic dissolves when you bring it into daylight. Dreams also happen across the architecture of sleep itself. A night is not one smooth descent into darkness. It cycles through different stages, with REM periods often becoming longer later in the night. This is why some of the most vivid dreams are remembered near morning. Your brain is closer to waking. The dream may be longer or more elaborate, and the memory has a better chance of surviving the transition into consciousness. But even then, the dream's time is not the same as clock time. It is shaped by brain chemistry, sleep stage, emotion, and the strange freedom of a world with fewer physical constraints. In a dream, the sun does not have to rise because Earth turned. A decade does not require 10 years. A place does not need to be built before you enter it. The dream simply presents the result, and your mind accepts the result as if the missing time has somehow already happened. This is what makes dream time so haunting. It reveals that your sense of duration is not only measured by clocks. It is created by attention, sequence, expectation, memory, and emotional weight. Waking life is held in place by the shared rules of the physical world, but dreaming shows how easily the mind can generate another kind of time when those rules loosen. And maybe that is why dreams can stay with you after waking. They do not only show impossible images, they show the hidden flexibility of experience itself. They remind you that a minute can feel endless if the mind fills it with intensity, and a whole night can vanish if consciousness leaves no trace behind. When you dream, you enter a private universe where time is no longer a road beneath your feet, but a fabric made from feeling, memory, and sudden transformation. And when you wake, the clock may tell you how long you slept, but it cannot fully tell you how long you were gone. How fear can slow down your sense of time. There are moments when fear does not merely enter the body. It seems to reach for time itself and stretch it with cold hands. A car suddenly swerves too close. A glass slips from a shelf. A dog lunges from behind a fence. Someone shouts your name in a voice that does not sound ordinary. In that instant, the world can feel as if it has slowed down. The falling object turns in the air with impossible clarity. A face freezes into sharp detail. Your own heartbeat becomes loud, and a fraction of a second feels wide enough to hold an entire thought. But time outside you has not actually slowed. The clock on the wall has not changed its rhythm. The earth has not paused. What changes is the brain's relationship to the moment. Fear is one of the strongest forces that can reshape your sense of time, because the brain treats danger differently from ordinary life. When something threatening happens, your nervous system rapidly shifts into survival mode. The amygdala, a brain region deeply involved in detecting threat and emotional importance, becomes highly active. Stress chemicals such as adrenaline and noradrenaline help prepare the body to act. Your heart beats faster. Your breathing changes. Blood moves toward muscles. Attention narrows. The brain stops treating the world as background and begins searching for anything that might matter. Movement, sound, distance, escape, impact, expression, intention. This intense focus can make the moment feel expanded, not because your brain has become a supernatural camera, but because it is prioritizing information with unusual urgency. In danger, the mind does not want beauty, depth, or reflection. It wants relevance. It wants to know what can hurt you, where it is, how fast it is moving, and what you can do next. That urgency can make perception feel sharper, and sharpness can be mistaken for slowed time. Yet the science is more subtle than the feeling. Some experiments suggest that during frightening events, people often believe time slowed down afterward, but their actual moment-by-moment perception may not have sped up in the way they assume. In one famous type of study, people exposed to intense fear did not show clear evidence that their visual processing became fast enough to read rapidly changing information that would normally be unreadable. What did change was their memory of the event. Fear can make the brain store more detail, or at least store the emotional event more strongly. When you later look back on the frightening moment, the memory contains more vivid fragments than an ordinary second would contain. The sound, the angle, the face, the body sensation, the sudden decision. Because the memory is dense, your mind may conclude that the event must have lasted longer. This is one of the strangest truths about fear and time. The slow motion feeling may partly be created after the fact, when the brain looks back at a highly detailed memory and mistakes detail for duration. A normal second leaves a thin trace. A fearful second can leave a thick one. And when the mind measures the thickness of the trace, it feels as if more time must have passed. This does not make the experience fake. It means the experience is built from both perception and memory. Fear changes what the brain records, and what the brain records changes how long the event feels when remembered. There is also a second layer. During fear, attention becomes less scattered. In ordinary life, your awareness drifts between thoughts, habits, background noises, and small distractions. But when danger appears, irrelevant things disappear. The mind becomes intensely present, sometimes painfully present. This concentration can make time feel slower because you are no longer skimming over the moment. You are inside it with all systems engaged. A person walking casually down a street may barely notice 10 seconds passing. A person hearing footsteps behind them in the dark may notice every half second. The same amount of clock time can feel different depending on how much attention is packed into it. Fear packs attention tightly. It removes the luxury of drifting. It forces the brain to inhabit the moment as if the next movement could decide everything. This is why fear can create a strange form of clarity. People in accidents sometimes report noticing tiny details they would normally ignore. The pattern of glass, the color of a jacket, the silence before impact. The brain is not calmly appreciating detail. It is searching for survival-relevant cues. But because the search is so intense, the memory can later feel almost cinematic. And yet fear does not always sharpen time. Sometimes it fragments it. In extreme stress or trauma, the brain can become overwhelmed. Instead of clear slow motion, people may experience gaps, confusion, dissociation, or a sense that time has vanished completely. Some remember too much. Others remember almost nothing. Some feel frozen, unable to act, even though their body is flooded with alarm. This matters because fear is not one single experience. It depends on intensity, context, past experience, the person's body, and whether the situation feels controllable. Mild fear can heighten attention. Extreme fear can break the continuity of experience. The same system built to protect you can, under too much pressure, become disorganizing. That is why a frightening moment can later feel unreal, as if it happened both too fast and too slowly, as if the mind could not decide what kind of time it had been inside. Fear also changes time because it is connected to prediction. The brain is always trying to anticipate what will happen next, but fear makes prediction urgent. If danger is approaching, the mind leans forward aggressively, trying to calculate outcomes before they arrive. Will the car stop? Will the person attack? Will the object hit the ground? Will there be pain? This forward-leaning state can make the present feel stretched because your brain is filling it with possible futures. A single second becomes crowded with branches. One part of you is seeing what is happening. Another part is preparing for what might happen. Another part is already imagining the consequence. The moment feels longer because it is not mentally empty. It is packed with simulations. But once the danger passes, the body may tremble, not only because of what happened, but because of everything that almost happened. Fear makes time heavy with near futures that never fully arrive. This is why even a close call can stay with you. The event may have been brief, but your nervous system treated it as a doorway into many possible endings. And perhaps that is the deeper reason fear alters time so powerfully. Fear tells the brain that the next second matters more than usual. Most seconds are allowed to pass quietly. Fear marks a second as important, and importance changes how the mind handles it. A peaceful second can dissolve. A dangerous second can become carved into you. This is not weakness. It is biology doing what biology was shaped to do. Long before clocks, calendars, or language, survival depended on noticing threat quickly and remembering it well. The animal that remembered the place where danger appeared had a better chance of avoiding it later. The nervous system learned to treat fear as a teacher, even when the lesson was painful. But in modern life, this same system can overfire. A harmless sound can feel urgent. A social rejection can feel like danger. An anxious thought can slow time in the body, making minutes feel trapped and endless. Fear does not need a lion in the grass. Sometimes it only needs an imagined consequence, and the body responds as if the future has already stepped into the room. This is where understanding becomes a form of gentleness. When fear makes time slow down, it does not mean you are losing your mind. It means your brain is changing the resolution of experience, narrowing attention, strengthening memory, and preparing the body for action. The moment feels stretched because your system has decided it is important enough to record. And maybe that knowledge gives you a little distance from the terror. Fear can bend your sense of time, but it is not proof that time itself has turned against you. It is proof that your brain is trying, sometimes clumsily, sometimes intensely, to keep you alive. So the next time fear makes a second feel enormous, remember that you are not experiencing time as a machine would measure it. You are experiencing time as a vulnerable living body measures it, by danger, attention, memory, and the urgent need to survive. And when the fear passes, when the world resumes its ordinary speed, you may realize that the slowest moments in life are often the ones where the mind is most awake. Not because they are peaceful, but because something inside you knows they may change everything. Why boredom makes time feel heavy. Boredom is the strange weight of time when nothing outside you feels strong enough to carry your attention away. You sit in a waiting room, stare at a loading screen, listen to a conversation that does not reach you, or lie awake while the night refuses to move, and suddenly minutes feel dense, almost physical, as if time has gained mass. Nothing dramatic is happening, and yet the moment feels difficult to endure. This is the paradox of boredom. It is not the presence of pain, exactly, but the absence of meaningful engagement, and that absence can become its own kind of pressure. Your brain is not built to experience time as an empty container. It experiences time through attention, expectation, reward, movement, purpose, and change. When those things become thin, the mind starts noticing the passing of time itself. Usually, when you are absorbed in something, a conversation, a problem, a game, a piece of music, a walk through a new place, your attention is attached to events. It moves from detail to detail, question to answer, sound to meaning, action to consequence. Time becomes almost invisible because your mind is busy with what time contains. But boredom removes the contents or makes them feel too weak to matter, then attention has nowhere satisfying to land. It circles back on itself. You begin checking the clock, shifting your body, counting the remaining minutes, noticing your own impatience, and the more you monitor time, the heavier it becomes. This is one of the clearest reasons boredom stretches the present. Attention aimed at time makes time feel louder. A watched minute does not physically grow longer, but it can become psychologically crowded because you are measuring it from the inside. The brain keeps asking, has enough happened yet? Has this ended yet? Is there something else to do? And when the answer keeps returning as no, the moment thickens. Boredom is often misunderstood as simple laziness or lack of activity, but science sees it more carefully. Boredom usually involves wanting to be engaged while feeling unable. unwilling, or uncertain about how to become engaged. That distinction matters. If you are peacefully resting, the quiet may feel restorative. If you are choosing stillness, a silent room can feel gentle. But boredom has a restless edge. It is not just doing nothing. It is wanting something from the moment and not receiving it. Your brain detects a mismatch between your need for stimulation or meaning and the situation you are in. That mismatch creates discomfort. In this way, boredom can act like a signal, almost like hunger, but for attention and purpose. Hunger tells the body it needs nourishment. Boredom tells the mind that the current situation is not offering enough value, novelty, challenge, or meaning. It pushes you to explore, to seek, to change state. This is why boredom can lead to creativity, but also to bad decisions. A bored mind may pick up a book, invent a story, reorganize a room, start a new project, or finally face a thought it has avoided. But it may also scroll endlessly, gamble, provoke conflict, snack without hunger, or chase any quick reward that breaks the heaviness. Boredom is not empty. It is motivational energy with no clear direction. And when it has nowhere healthy to go, it can become irritation, restlessness, or even a quiet kind of despair. The biology beneath it is complex, but one important part involves reward. Your brain is constantly estimating whether something is worth attention. Is this useful? Is it new? Is it emotionally meaningful? Can I learn from it? Can I act on it? When the answer feels like no, the reward systems that normally help energize engagement may not activate strongly enough. The world becomes flat. You may still see the same objects, hear the same sounds, sit in the same body, but the moment loses grip. It does not pull you forward. And without that pull, time no longer feels like a stream of meaningful events. It feels like a room you are trapped inside. This is why monotonous situations can make time feel heavy, even if they are not physically difficult. Repetition reduces surprise. Predictability reduces curiosity. Lack of control reduces motivation. Waiting becomes especially uncomfortable because it combines low stimulation with blocked action. You are not only bored, you are suspended. You cannot fully leave, cannot fully begin the next thing, and cannot fully invest in the current moment. Time becomes a locked hallway between where you are and where you want to be. That feeling of blocked movement is essential. Boredom often becomes heavier when you feel you have no agency. A long lecture you did not choose, a delayed flight, a slow work shift, a traffic jam, a forced pause with nothing meaningful to do. These situations stretch time because the mind keeps preparing to move, while reality keeps refusing permission. The body is present, but intention is elsewhere. You are split between now and later, and that split makes the present feel resistant. There is also a strange self-awareness inside boredom. When nothing outside you demands attention, the mind often turns inward. You notice your thoughts, your dissatisfaction, your lack of desire, your own inability to care. This can be uncomfortable because boredom reveals something we usually avoid. Attention is not fully under our command. You can tell yourself to care, but caring does not always obey. You can force your eyes onto a page, but interest may not arrive. You can sit in silence, but peace may not come. Boredom exposes the gap between wanting to be engaged and actually being engaged. And in that gap, time becomes personal. A boring hour is not just an hour without events. It is an hour in which the self feels underused. The mind senses that it could be somewhere else, doing something else, becoming something else, and yet it remains fixed in a moment that feels too small for it. This is why boredom can feel almost insulting. It makes consciousness feel wasted. But boredom also has a hidden intelligence. It can reveal when your life has become too repetitive, when your attention has been trained to need constant stimulation, when your work lacks meaning, when your environment offers no challenge, or when you are avoiding the discomfort of choosing. In a world full of instant entertainment, boredom can feel more threatening than it used to, because the brain has easy escapes. A few seconds of emptiness, and the hand reaches for the phone. A moment of waiting, and a screen appears. This does not mean technology is evil, but it does mean the mind can lose practice being with low stimulation time. If every small silence is immediately filled, boredom never has time to transform into reflection. The first layer of boredom is often irritation, but beneath it there can be imagination. The mind needs open space to wander, combine ideas, revisit memories, and form new connections. Many creative insights appear not during intense focus, but when the mind is lightly unoccupied, walking, showering, resting, staring out a window. The difference is whether boredom becomes dead emptiness or fertile emptiness. Dead boredom says, nothing matters here. Fertile boredom says, something new may need room to appear. The same quiet can crush you or open you, depending on whether the mind finds a path through it. This does not mean all boredom is good. Chronic boredom can be painful and is linked with stress, impulsive behavior, low mood, and dissatisfaction. But occasional boredom is not a failure of life. It is part of how the brain regulates attention and searches for meaning. It asks you, sometimes unpleasantly, whether the moment you are in deserves your mind. And if it does not, boredom pushes you to change the moment, or change how you are meeting it. The heavy feeling of time is therefore not just a nuisance. It is information. It tells you that attention has become detached from purpose. It tells you that the mind is awake enough to want more, but not yet directed enough to find it. And perhaps that is why boredom feels so different from calm. Calm is spacious because you have accepted the moment. Boredom is heavy because you are resisting it while remaining inside it. One lets time breathe. The other makes time press against you. So the next time a minute feels strangely long, do not dismiss it as nothing happening. Something is happening. Your brain is searching for significance and failing to find it. It is measuring the emptiness between desire and engagement. It is asking whether you should endure, escape, create, rest, or pay attention more deeply. Boredom makes time feel heavy because it removes the disguises that usually hide time from you. It leaves you alone with the raw fact that moments are passing and that your mind wants them to mean something. And maybe, if you listen carefully, boredom is not only the weight of an empty moment. It is the quiet pressure of a life asking to be filled with something real. Why beautiful moments feel too short. The cruelest thing about beauty is that the moment you finally notice it, it has already begun to leave. A sunset reaches its richest color and then starts fading. A song opens something in you, and before you are ready, the final note is already dissolving. A conversation becomes warm, rare, and honest, and then someone has to go. A child laughs, a hand stays in yours for a few seconds. A room fills with a kind of peace you did not know you needed, and the mind quietly whispers, stay. But beautiful moments rarely feel like they stay. They feel brief, almost unfairly brief, as if time becomes thinner around the things you want most to keep. The reason is not that clocks speed up during joy. It is that your brain changes how it distributes attention, emotion, and memory when an experience feels deeply rewarding. During a beautiful moment, you are often less focused on measuring time and more absorbed in the experience itself. Your attention is not standing outside the moment with a stopwatch. It is inside the music, inside the face, inside the warmth, inside the meaning. When the mind is deeply engaged, the monitoring of time can fade into the background. You stop checking how long something is lasting because the experience feels worth entering completely. This is one reason pleasure can seem to pass quickly while it is happening. The brain is busy receiving, feeling, responding, and connecting. It is not asking how many minutes have passed, as urgently as it does during waiting or discomfort. But there is another layer, and it is more delicate. Beautiful moments often feel too short because desire changes your relationship with duration. When something is unpleasant, you want it to end, and that wanting makes every second noticeable. When something is beautiful, you want it to continue, and that wanting makes the ending feel too soon, no matter how long it lasted. A wonderful evening can last 4 hours and still feel brief because the mind measures it not only by clock time, but by how much it wishes remained. The shortage is emotional, not always temporal. You do not simply say, "That was short." You feel, "I was not finished being there." This is why even a long holiday can feel like it vanished the moment you return home. The experience may have contained many hours, many meals, many streets, many conversations, but the wanting outlives the event. The mind compares the beauty of the experience with the impossibility of keeping it, and the result is a feeling of sudden loss. Neuroscience helps explain part of this. Rewarding experiences involve brain systems connected to motivation, pleasure, learning, and attention. Dopamine is often discussed in this context, though it is not simply a pleasure chemical in the shallow sense. It is strongly involved in wanting, anticipation, salience, and learning what matters. Before a beautiful event, anticipation can stretch time. The days before a trip, a meeting, or a long-awaited moment may feel slow because the brain keeps reaching toward the future. But when the event finally arrives, attention becomes absorbed, novelty becomes immediate, and the moment can feel as if it is passing too quickly. Desire stretched the waiting, then immersion compressed the living. This creates one of the strange asymmetries of human time. Wanting something can make time heavy before it arrives, while having it can make time disappear. And after it ends, memory begins doing its own work. Your brain does not store every second equally. It tends to preserve emotional highlights, beginnings, endings, surprises, and moments of strong meaning. This is why a beautiful experience may be remembered as a glowing sequence of peaks, rather than a full, continuous recording. You remember the first sight of the ocean, the one sentence that touched you, the meal under warm light, the moment everyone laughed, the final goodbye. The ordinary connective tissue, the walking, waiting, adjusting, small pauses, fades. Later, when you look back, the memory feels both rich and brief. Rich because the emotional highlights remain. Brief because much of the duration between them has been compressed. The remembered experience becomes like a necklace made only of bright stones, with the thread almost invisible. This does not mean the beauty was less real. It means memory edits for meaning. It keeps what mattered most and lets the rest become atmosphere. There is also something called duration neglect, a tendency for the remembered value of an experience to depend less on its total length and more on its emotional intensity and ending. A beautiful moment that ends softly may feel complete, even if short, while one that ends abruptly can feel stolen, even if it lasted longer. This is why the ending of a moment matters so much. The goodbye can color the whole day. The final note can change the feeling of the song. The last look can become the part your mind returns to. Time in memory is not a neutral line. It is weighted by emotional gravity. The moments that mean the most bend your memory around them. And perhaps this is why beauty and sadness are so often close together. A beautiful moment reveals value at the same time it reveals impermanence. You feel how precious something is because you sense it cannot remain exactly as it is. The sunset is beautiful partly because the light is changing. A child's voice is moving toward another age. A loved face is alive inside a body that time will keep altering. A season becomes dear because it will not stay. Beauty sharpens awareness of passing, and passing sharpens beauty. If a perfect moment could last forever without changing, it might eventually stop feeling like a moment at all. It might lose the contrast that lets you recognize it. Much of beauty depends on fragility, the trembling color before night, the brief bloom before petals fall, the rare conversation that could not have been planned. The fact that it will end is not separate from why it moves you. It is part of the structure. Still, knowing this does not remove the ache. You can understand the psychology, the memory, the attention, the reward systems, and still feel that certain moments leave too quickly. That is because the ache is not only confusion, it is love pressing against time. You want the world to pause where it becomes meaningful. You want the ordinary laws to make an exception for the hour that healed you, the voice that steadied you, the light that made everything feel briefly forgiven. But time does not stop for beauty. It gives beauty its shape by letting it pass. And maybe the gentlest wisdom is not to grip beautiful moments so tightly that the fear of losing them prevents you from entering them. The mind can ruin a beautiful moment by watching it disappear while it is still happening. You have felt this before. Happiness arrives, and almost immediately another thought says, "This will end." then part of you is no longer present. It is already grieving. But presence does not mean denying the ending. It means letting the ending remain distant enough that the moment can breathe. Beautiful moments feel too short because your brain stops counting while your heart starts wanting. They feel too short because memory saves their brightest pieces and lets the rest blur. They feel too short because what matters always seems to deserve more time than the universe gives it. And yet the answer is not to make beauty last forever. It is to meet it more fully while it is here, to listen to the song without reaching for the final note, to watch the light without mourning the dark too early, to let the hand in yours be enough while it is still warm, because perhaps a beautiful moment is not meant to be owned. It is meant to pass through you clearly enough that, even after it ends, something in you remains brighter because it happened. How memory stretches and shrinks time. Your life may feel like one continuous timeline, but your memory quietly cuts it, stretches it, compresses it, and rearranges its weight until some hours become enormous and whole years almost disappear. You do not remember time the way a clock records it. A clock gives every second the same value, whether you are waiting in silence, laughing with someone you love, walking through a new city, or staring at the same ceiling in a room you have known for years. Memory does not work like that. Memory is selective. It is emotional. It is built from attention, meaning, novelty, and change. This is why 2 days with the same number of hours can become completely different sizes inside you. One day can feel short while you are living it, then become huge in memory because it was filled with firsts, surprises, and strong feelings. Another day can feel long while you are trapped inside it, then shrink almost to nothing later because your brain saved very little from it. The strange part is that your remembered life is not measured by duration itself, but by how much the mind had reason to record. A year full of repeated routines can collapse into a blur because the brain groups similar experiences together. It does not need to store every identical commute, every familiar meal, every ordinary morning in full detail. It compresses them, like folding many pages into one. But a single unusual afternoon can remain bright for decades because it broke the pattern. Your brain noticed it. It marked it as different. It gave it a place. This is one of the main ways memory stretches time. It creates landmarks. A landmark in memory is not only a famous place or a dramatic event. It can be the first day in a new home, the moment you heard life-changing news, the smell of a hospital corridor, the sound of rain during a conversation you never forgot, the first time you realized someone was leaving emotionally before they left physically. These events divide your life into before and after. They give memory edges, and once your mind has edges, time becomes easier to expand. When you look back on a period filled with many distinct landmarks, it feels longer because there are more mental places to visit. But when a period has few landmarks, it shrinks, even if it lasted months. This is why memory can make life feel uneven. It does not preserve the exact length of experience. It preserves the density of significance. Scientists often distinguish between the time you feel while an event is happening and the time you judge afterward. During an event, your sense of time depends heavily on attention and engagement. Afterward, your judgment depends more on how much you remember. A busy, exciting day may fly by in the moment because you are absorbed, yet feel long in memory because it left many traces. A boring day may drag while happening because you are monitoring time, yet feel short afterward because almost nothing distinctive was stored. This is not a contradiction. It is two different clocks inside the mind. The experiencing self lives through attention. The remembering self measures by traces. And because your identity is built largely from memory, the remembering self often has the final word. It decides whether a chapter of life feels rich or empty, long or brief, meaningful or lost. But memory does more than store events. It organizes them into stories. Your brain does not keep your past as a perfect archive of raw footage. It rebuilds scenes from fragments, images, emotions, places, words, bodily sensations, and meanings you added later. Each time you recall something, you are not simply opening a sealed container. You are reconstructing. That reconstruction can change the felt length of the past. A childhood summer may become larger because memory has filled it with atmosphere, warmth, and repeated retellings. A painful period may feel endless because every recalled detail is connected to stress, anticipation, and emotional intensity. A relationship that lasted only a few months may occupy more inner space than years of routine because it changed your sense of self. Memory stretches what mattered and shrinks what felt repetitive, even when the calendar would disagree. This is also why emotional events can distort the timeline. Strong emotion acts like a highlighter. It tells the brain, "This matters, keep this." But emotion does not always preserve time accurately. It can make a brief moment feel enormous because the memory contains many charged details, or because you have revisited it so often that it has gained more and more weight. Repetition in memory can create the illusion of size. Something that happened once may feel like it lasted longer because your mind has returned to it hundreds of times. In that sense, you do not only live through events once. Some events continue taking up time inside you long after the clock has moved on. A regret can keep stretching because you replay it. A joyful memory can keep glowing because you revisit it. A fear can remain large because the nervous system keeps treating it as unfinished. Memory is not just a record of time. It is a place where time continues to echo. There is also a process called event segmentation, where the brain naturally divides experience into units. Entering a room, starting a conversation, receiving news, leaving a place, arriving somewhere new. These boundaries help memory organize life. When many boundaries occur, a period feels fuller. Travel often feels long in memory because it contains many scene changes. Airports, roads, rooms, meals, faces, decisions, weather, unfamiliar sounds. A routine week at home may contain fewer boundaries, so it becomes one smooth surface. The brain compresses what has no clear cuts. This is why changing your environment, learning something new, or doing something outside your normal pattern can make time feel larger in memory. You are giving the brain more chapters, not necessarily happier chapters, but more distinguishable ones. And distinguishable time feels more lived. Yet there is a haunting side to this. A life can be full of activity and still feel short in memory if the activities are too similar. You can be busy every day and still feel, months later, that nothing happened. The body was occupied, but memory was not marked. This is why people sometimes feel that time vanished during periods of work, stress, or digital repetition. The days were filled, but not with enough difference. The mind saved tasks, not moments. It saved outcomes, not textures. It survived the schedule, but did not gather many memories from it. And if memory is the way you later feel the size of your life, then attention becomes more than a mental habit. It becomes a way of giving time back to yourself. To notice something deeply is to make it harder for the moment to disappear. To create a boundary, ask a real question, go somewhere unfamiliar, learn a skill, speak honestly, observe the season, or let yourself feel an experience without rushing through it. These are ways of making time more visible to memory. You cannot slow the clock by force, but you can change what your future mind will have to hold. That is the quiet power hidden here. Memory stretches and shrinks time because your life is not only what happens to you, it is what your brain records, organizes, revisits, and gives meaning to. The past you carry is not the whole past. It is the shaped past, the edited past, the emotionally weighted past. Some moments are enlarged because they became part of who you are. Others are reduced because they left no clear trace. And perhaps this is why life can feel both long and brief at the same time. Long, because certain memories contain entire worlds. Brief, because so much ordinary time slips through without being held. So when you wonder where the years went, the answer may not be that they were empty. It may be that memory folded them too tightly. And when one small moment from years ago still feels close, it may be because your mind never filed it away as finished. Memory is the sculptor of inner time, pressing some seconds into monuments and letting other months fall into mist. And if you listen carefully, this truth is not only sad, it is an invitation. Live in a way that gives your memory something real to keep. Why your body has hidden clocks inside it. Inside your body, there is no single clock ticking in the dark. there are millions of tiny timekeepers quietly deciding when you should sleep. Digest, heal, think, burn energy, and wake before you ever look at the hour. You may believe time enters your life from the outside, from phones, alarms, calendars, sunlight through the curtains, or the pressure of appointments. But your body is not merely responding to clocks around it. It carries clocks within it. They are not shaped like hands on a dial. They do not tick with sound. They are made of cells, genes, hormones, temperature changes, chemical signals, and repeating cycles that rise and fall across the day. At the center of this living system is a small region in the brain called the suprachiasmatic nucleus, sitting deep above the place where the optic nerves cross. It is tiny, but it acts like a master coordinator. It receives information about light from the eyes, especially morning light, and uses that information to help synchronize the body with the outside world. This matters because the planet turns once every day, and life on Earth evolved under that rhythm of light and darkness. Your body learned to anticipate the world before it happens. It does not wait until morning to begin preparing you for wakefulness. It does not wait until night to begin changing the chemistry of sleep. It predicts. It schedules. It quietly adjusts your biology before your conscious mind gives permission. This is why you can sometimes wake just before an alarm. This is why hunger can arrive near the same time each day. This is why your body temperature, alertness, blood pressure, digestion, and hormone levels all follow patterns instead of behaving randomly. One of the most famous signals in this system is melatonin, a hormone that tends to rise in the evening when darkness tells the brain that night has arrived. Melatonin does not knock you unconscious like a sleeping pill. It is more like a biological message saying, the body's night has begun. Another important rhythm involves cortisol, which often rises toward morning, helping prepare the body to become alert and active. But these are only the visible surface of a much deeper timing network. Almost every major organ has its own clock-like system. Your liver has timing rhythms that influence how it processes nutrients. Your gut has rhythms that affect digestion and movement. Your pancreas times aspects of insulin release and blood sugar control. Your heart and blood vessels follow daily patterns too. Even immune activity can vary across the day, meaning the body's defenses are not equally tuned at every hour. This is the hidden truth. You are not one machine running at the same setting all day. You are a living orchestra, and different instruments enter at different times. The brain may conduct, but the organs also keep their own rhythms, listening to signals from light, food, activity, sleep, and temperature. This is why timing can change how the same behavior affects you. A meal eaten at one time of day may not be processed exactly like the same meal eaten at another time. Exercise in the morning can feel very different from exercise late at night. A screen's bright light may be harmless at noon, but disruptive before sleep because it arrives at the wrong biological moment. Your body is not only asking what you do, it is asking when you do it. And when the outside schedule fights the inside clocks, the body feels the conflict. Jet lag is one example. When you cross time zones quickly, the clock on the wall changes immediately, but your inner clocks do not instantly follow. Your brain may still think it is night while the city around you is in daylight. Your stomach may expect food when no meal is coming. Your sleepiness may arrive at the wrong hour. Shift work can create an even deeper challenge, because the body is asked to stay alert when it expects darkness and rest, then sleep when the environment is bright and active. Over time, repeated misalignment between internal clocks and external demands may affect mood, metabolism, sleep quality, and overall health. This does not mean one bad night ruins you. The body is resilient, but it does mean rhythm is not decorative. It is part of biology's architecture. There are also faster clocks inside you. Your heart beats in cycles. Your breathing rises and falls. Brain activity moves through changing patterns across sleep. Hormones may pulse rather than stay flat. Even attention can move in waves, with moments of sharper focus and moments where the mind naturally softens. The body is not a straight line. It is layered rhythms within rhythms. Seconds, minutes, hours, days, months, seasons, and age. Some rhythms are obvious because you can feel them, like a heartbeat after climbing stairs. Others are hidden until they are disrupted. You may not notice your digestive timing until you eat at strange hours. You may not notice your sleep rhythm until travel breaks it. You may not notice the body's need for regularity until irregularity makes everything feel slightly wrong. The hidden clocks become visible when they fall out of tune. And this is where the science becomes quietly personal. You are not only a mind making choices in abstract time. You are a body trying to keep promises with the sun, with darkness, with food, with rest, with movement, with repetition. Your cells do not understand ambition the way you do. They do not care that a deadline is urgent, that a video is unfinished, that a message arrived late, that the world expects constant availability. They respond to signals. Light at night tells them one thing. Food at midnight tells them another. Irregular sleep tells them another. Calm morning light, regular meals, movement, and darkness tell them something else. Modern life often asks the body to ignore ancient rhythms, but the body cannot fully escape the planet it evolved on. It still carries dawn and dusk inside its chemistry. It still listens for patterns older than language. This does not mean you must live perfectly or fear every late night. It means your body is more rhythmic than your schedule admits. It means tiredness, hunger, alertness, and rest are not random failures of willpower. They are signals from a timed biological system trying to coordinate trillions of cells into one life. And perhaps the most humbling part is that your sense of self depends on this coordination. When your clocks are aligned, you may simply feel normal, as if nothing special is happening. But that normal feeling is a triumph of timing. Brain, liver, heart, gut, hormones, temperature, sleep pressure, and light response are all quietly agreeing enough to let you move through the day as one person. When they fall out of rhythm, you may feel foggy, hungry at strange hours, emotionally thin, restless at night, or heavy in the morning, not because you are weak, but because the orchestra is struggling to hear the conductor. Your body has hidden clocks inside it because life on a rotating planet had to learn the future before it arrived. It had to prepare for sunrise, darkness, food, danger, repair, and rest. And now, even in a world of artificial light and digital time, those ancient clocks continue their soft work beneath your awareness, reminding you that time is not only something you read, it is something you are made of, the silent rhythm of circadian time. There is a tide inside you that rises and falls every day without making a sound, and most of the time you only notice it when it is disturbed. You feel it when morning light makes the mind slowly return from sleep, when alertness sharpens at certain hours, when your body grows heavy before bed, when hunger arrives with strange timing, when a late night makes the next day feel unreal, or when jet lag turns noon into midnight inside your bones. This hidden tide is circadian time, the roughly 24-hour rhythm that helps living organisms stay aligned with the turning of Earth. It is not simply a sleep schedule, and it is not just a habit you can change by willpower alone. It is a biological timing system built into the deep architecture of life, a silent rhythm that prepares the body for the predictable cycle of light and darkness before each part of the day arrives. The word circadian comes from the idea of about a day, and that about matters. Your inner rhythm is not always exactly 24 hours on its own. If a person were kept in constant dim conditions without clocks, sunlight, or social cues, the body's natural rhythm might drift slightly longer or shorter than the day outside. This is why the body needs signals from the environment to reset itself. The most powerful signal is light, especially light reaching the eyes in the morning. Inside the retina, there are special light-sensitive cells that are not mainly for forming images, but for telling the brain how bright the world is. They send information to the brain's central clock, helping it decide whether the body should be shifting toward wakefulness or preparing for night. This means your eyes are doing more than seeing shapes and colors. They are helping your body know where it is in time. Morning light tells the internal clock to anchor the day. Evening darkness allows the body to move toward rest. Artificial light at night, especially when bright and close to the eyes, can confuse that message. Not because light is evil, but because your biology evolved under skies that grew dim after sunset. For most of human history, night was not filled with glowing screens, ceiling lights, and endless stimulation. Darkness was a signal. The body listened to it. Circadian time works by coordinating many systems so they do not all act at once. Your core body temperature tends to dip during the night and rise before waking. Alertness often increases through the morning and can reach strong points during the day, while sleepiness may deepen at night when the circadian system and sleep pressure begin working together. Sleep pressure is different from circadian rhythm. Sleep pressure builds the longer you stay awake, like a slow accumulation of need. Circadian rhythm is more like a daily schedule of readiness and rest. You can feel the difference when you are very tired but still get a strange second wind at night, or when you wake too early and cannot fall back asleep even though you did not sleep enough. One system says, you need sleep. Another says, this is a time when the body is becoming alert. Your experience is shaped by the conversation between these forces. This is why sleep is not just about how many hours you get, but also when those hours happen. 8 hours of sleep at a biologically mismatched time may not feel the same as 8 hours aligned with your internal night. The body does not treat all hours as equal. A meal, a workout, a difficult conversation, a burst of light, or a stressful task may land differently depending on where your circadian system is. This is not a moral rule or a rigid command. It is biology's way of organizing energy. The body is constantly deciding what to prioritize: digestion, repair, alertness, immune activity, hormone release, temperature regulation, memory processing, and emotional balance. Circadian timing helps arrange these priorities across the day so the body does not run every process at full power all the time. A living organism is not a lamp that simply turns on and off. It is more like a city with schedules: deliveries in the morning, cleaning at night, traffic rising and falling, quiet systems working after dark while the visible world sleeps. But modern life often asks that city to ignore its own schedule. People work under bright light at midnight, eat heavy meals when the body expects rest, sleep beside buzzing phones, wake before sunrise after too little darkness, travel across time zones, and then blame themselves for feeling foggy, anxious, or strangely detached. The body can adapt to many things, but it does not adapt instantly. Circadian rhythm changes gradually, and some people's rhythms naturally lean earlier or later. This is why morning people and night owls are not always just disciplined or lazy versions of one another. Chronotype, the tendency to feel more alert earlier or later in the day, has biological influences. Age matters too. Teenagers often shift later, feeling more awake at night and sleepier in the morning, while older adults often shift earlier. Social schedules do not always respect this, and when someone's biological timing and social obligations clash, they can experience what researchers call social jet lag. The body living in one time zone while society demands another. You do not have to board a plane to feel displaced in time. Sometimes the clock on the wall and the clock in your body simply disagree. Circadian rhythm also reaches into mood and mental clarity. Many people feel emotionally different at different hours, not because their personality changes, but because brain chemistry, fatigue, light exposure, and bodily state are shifting together. A worry at midnight can feel larger than the same worry in morning light. A decision made after poor sleep may feel heavier. A quiet afternoon dip in alertness can make the mind feel dull, even when nothing is truly wrong. These changes are not imaginary. They are part of the body's daily rhythm, and understanding them can make you gentler with yourself. Not every low mood is a revelation. Not every late-night fear deserves to be treated as truth. Sometimes the mind is speaking from a tired biological hour. This does not mean circadian rhythm explains everything, but it gives context to experiences that otherwise feel personal and mysterious. There are even people whose circadian clocks do not synchronize easily with the 24-hour day, such as some totally blind individuals who cannot receive light signals in the usual way. Their internal rhythm may drift, causing cycles of good sleep and poor sleep as their biological night moves in and out of alignment with the outside world. This shows how essential light is, not merely for vision, but for temporal belonging. To belong to a day, the body must be told when day is. And yet circadian time is not only a human story. Plants open and close their leaves, animals migrate, insects feed, flowers release scent, marine creatures respond to tides and light, and countless organisms carry internal rhythms shaped by the planet's rotation. Life learned the rhythm of Earth so deeply that the day became written into cells. This is the quiet grandeur of circadian time. It is cosmic and intimate at once. The same turning planet that gives the sky its sunrise also shapes when your temperature rises, when your attention sharpens, when your body prepares to sleep, and when your cells begin certain forms of repair. You are not separate from the motion of Earth. You are synchronized to it. Even indoors, even under artificial light, even surrounded by digital clocks, your body remains an ancient listener, waiting for dawn, reading darkness, measuring the day through signals older than civilization. And maybe this is why circadian disruption feels so strange. It is not just tiredness, it is a kind of temporal dislocation, a feeling that your body has lost its place in the day. When your rhythm is aligned, you may not notice anything special. You simply feel more coherent. Morning becomes morning inside you. Night becomes night. Hunger, rest, focus, and sleep feel less like battles and more like waves arriving in order. But when the rhythm is broken, the world can feel slightly unreal, as if the body is awake at the wrong chapter. The silent rhythm of circadian time teaches that health is not only what you do, but when you do it. Not only how much you sleep, but whether sleep arrives in harmony with the body's night. Not only whether you see light, but whether that light comes when your brain needs it most. It also teaches something softer. You are rhythmic by nature. You were not built to be equally alert, equally productive, equally hungry, equally calm, and equally bright at every hour. The body has phases, and there is wisdom in respecting them. A world obsessed with constant output often forgets that living systems pulse. They rise and fall. They open and close. They need light, then dimness, effort, then recovery. So when evening comes and your thoughts begin to slow, or when morning light gradually returns you to yourself, there is more happening than routine. Your body is keeping in agreement with the turning earth. A silent rhythm is moving through you, reminding every cell that time is not only counted by clocks. It is breathed, dimmed, brightened, slept through, awakened into, and carried quietly in the chemistry of being alive. Why midnight feels different from morning. Midnight feels different from morning because the same mind does not meet the world from the same biological, emotional, or sensory place at every hour. At midnight, a room can feel larger than it is. A small worry can become strangely sharp. A memory you ignored all day can return with a weight it did not have under sunlight. The streets outside grow quieter. The body becomes heavier, and the world seems to withdraw from you, leaving your thoughts with fewer distractions and more echo. Morning, by contrast, often arrives with edges. Light through a window, movement outside, messages beginning, voices returning, the body warming toward action, the sense that the world is starting again. The difference is not only poetic, it is built from biology, environment, attention, and meaning. Midnight is not simply a darker version of morning, it is a different internal state. By late night, if you have been awake for many hours, sleep pressure has built inside the brain. This pressure is partly linked to chemicals that accumulate during wakefulness and make the body want rest. As tiredness increases, the mind does not always become peacefully sleepy. Sometimes it becomes unstable, attention weakens, emotional control can become thinner, and the brain may have less energy for balanced thinking. Problems that would feel manageable in daylight can seem enormous at night because the tired brain has fewer resources to regulate them. The prefrontal regions involved in planning, self-control, and careful perspective may not operate with the same strength when you are exhausted, while emotional systems can still remain active. This is one reason late-night thoughts can become dramatic, repetitive, or darker than they truly deserve to be. The mind is not always revealing a deeper truth at midnight. Sometimes it is thinking with a tired body. That distinction matters. A fear at 1 a.m. can feel like a prophecy, but it may simply be a signal passing through fatigue, darkness, and isolation. Morning often changes the same thought, not because the external facts magically improved, but because your brain is in a different state, more rested, more light exposed, more oriented toward action, more supported by the return of ordinary structure. There is also the power of darkness itself. Human beings are visual creatures, and light gives the brain information, distance, shape, safety, and orientation. In low light, the world becomes less detailed. Corners soften, objects blur, silence becomes more noticeable. The brain begins filling gaps. This can make midnight feel intimate or unsettling, depending on your mood. Darkness reduces visual certainty, and where certainty decreases, imagination often expands. A coat on a chair becomes a figure for half a second. A sound in the hallway becomes meaningful before you know what caused it. A room you know perfectly well by day can feel slightly unfamiliar at night because your senses are receiving less information and your mind is doing more interpretation. Morning reverses this. Light returns detail to the world. The chair becomes only a chair. The hallway becomes only a hallway. The vague becomes named. The named becomes less threatening. This is one of the quiet gifts of morning. It gives form back to things that night made uncertain. But midnight is not only fear. It can also feel strangely honest. When the day's obligations fall away, when fewer people are watching, when messages stop arriving, a person can feel closer to thoughts they normally avoid. At night, the social world becomes quieter. There are fewer roles to perform, fewer tasks to complete, fewer reasons to keep the surface smooth. This can create a feeling of psychological exposure. You are left with yourself without the usual daylight costumes. Worker, student, parent, friend, stranger in public, person who has to answer, perform, decide, move. At midnight, the self can feel less defended. That is why late-night reflection can become deep, creative, or painfully vulnerable. Many people write, think, confess, imagine, or grieve more intensely at night because the external world stops interrupting the inner one. Morning tends to restore roles. It gives you a schedule again, a body to move, a set of tasks that pull the mind outward. Midnight pulls inward, morning pulls outward. Neither is more real. They reveal different layers of being. There is also a difference in possibility. Morning feels open because the day has not yet been spent. It carries potential action. Even if you are tired, morning suggests that something can be done. A message can be sent, a walk can be taken, food can be prepared, work can begin, a plan can be adjusted. Midnight often feels closed because many actions are unavailable or delayed. You cannot solve everything at midnight. You cannot call everyone, fix every problem, change every circumstance, or fully begin again while the world sleeps. This can make worries feel trapped. A problem in the morning may become a task. The same problem at midnight may become a loop. The mind keeps turning it over because the body cannot act on it yet. This is why night can make thought feel circular. It is not always that the problem is deeper. It is that action is blocked, and blocked action turns attention into rumination. Morning can break that loop simply by offering motion. Even small motion, opening curtains, drinking water, stepping outside, hearing other people awake, can remind the brain that life is not only thought. It is behavior, it is environment, it is contact with the world. Midnight also changes your sense of scale. During the day, your thoughts are surrounded by competing signals. Traffic, work, light, weather, conversation, errands, noise. A worry is one object among many. At night, the same worry can become the largest object in the room because there are fewer things beside it. The mind amplifies what remains. This is why a small regret can feel enormous in bed. It has no competition. There is no sunlight on the wall, no ordinary social rhythm, no practical task to dilute it. Attention becomes a magnifying glass. Morning does not necessarily erase the regret, but it places it back into a world with other dimensions. You remember breakfast, messages, temperature, responsibilities, The fact that your body exists beyond the thought. Daylight gives proportion. Night can remove proportion. And yet midnight can also create beauty for the same reason. With fewer distractions, music can feel deeper. A quiet conversation can feel more private. A city street can seem almost sacred when emptied of daytime urgency. The stars, if you can see them, become more present because the sun is no longer hiding them. The absence that makes fear louder can also make wonder louder. Midnight is the hour when the world becomes less crowded, and because of that, whatever remains can feel intensified. Morning's beauty is different. It is not usually the beauty of secrecy, but of renewal. Morning light changes color as the sun rises because it travels through the atmosphere at a low angle, scattering shorter blue light and allowing warmer tones to fill the sky. Birds often sing near dawn, partly because sound can travel well in the calmer air, and because singing helps mark territory and attract mates. Human neighborhoods begin producing small signs of life: footsteps, engines, doors, voices, kettles, routines. The brain receives these cues as evidence that the world is reassembling. This can create emotional relief. You may not have solved anything, but the world has returned to motion, and motion itself can feel like hope. There is even a phenomenon many people recognize without naming. Thoughts that feel unbearable at night often feel less absolute after sleep. Sleep does not simply turn consciousness off. It helps regulate emotion, process memory, restore attention, and reset parts of the body's chemistry. Poor sleep can make everything worse, but enough sleep can change the emotional tone of the same facts. This is why advice like "sleep on it" has some biological wisdom. It is not an escape from reality. It is an acknowledgement that the brain may judge reality differently after repair. Midnight and morning are therefore not just times on a clock. They are different relationships between the body and the world. Midnight is low light, reduced action, accumulated fatigue, quieter social signals, inward attention, and often a stronger pull toward memory, imagination, or rumination. Morning is returning light, renewed environmental detail, increased action possibility, social re-entry, and the body's gradual movement toward wakeful coordination. This is why the same person can feel like two different selves across the night and morning. Not because the self is false, but because the self is state-dependent. You are always you, but you is expressed through chemistry, sleep, light, hunger, temperature, safety, memory, and context. The midnight self may be more sensitive, more symbolic, more afraid, or more creatively open. The morning self may be more practical, more externally anchored, more capable of sorting what night made too large. And perhaps wisdom is learning not to let 1 hour claim the whole truth. Midnight may reveal what you have been too busy to feel, but it can also distort what fatigue has made fragile. Morning may restore clarity, but it can also bury the emotional messages that night uncovered. One asks you to listen inward, the other asks you to live outward. One darkens the room until thought becomes louder. The other returns the world until thought finds proportion again. So when midnight feels different from morning, it is not your imagination failing you. It is your body and mind moving through different phases of the same life, under different conditions of light, energy, silence, and possibility. The night does not always tell the final truth. How ancient humans first measured time. Before clocks had faces, before calendars had names, before hours were divided into numbers, ancient humans measured time by watching the world repeat itself. They did not begin with machines. They began with need. A hunter needed to know when animals would migrate. A gatherer needed to know when fruits would ripen. A community needed to know when cold would return, when rivers would flood, when planting might succeed, when darkness would fall, when the moon would be bright enough to travel at night. Time was not an abstract idea at first. It was hunger, safety, weather, birth, death, firewood, harvest, and survival. The first clocks were not built from metal or stone. They were built from attention. A shadow moving across the ground told people the sun had changed position. The moon's shape told them that nights were not all the same. The return of certain stars before dawn could signal that a season was approaching. The behavior of birds, plants, tides, insects, and herds became part of a living calendar written across the landscape. Ancient humans learned time not by escaping nature, but by reading it carefully. A day was the simplest rhythm because light and darkness divided life with unmistakable force. You did not need mathematics to feel the difference between sunrise and nightfall. The body itself knew. Work happened under light. Fire gathered people after dark. But once humans began paying closer attention, they noticed that the sun's path changed across the year. It rose and set at slightly different points on the horizon. Shadows were longer in some seasons and shorter in others. The height of the sun at noon changed gradually, then returned. This slow shifting gave early people a way to track not only days, but the larger breathing of the year. A simple upright stick, a gnomon, could reveal astonishing things. As the sun moved, the stick's shadow moved. As seasons changed, the shadow's length changed. With patience, a person could learn when the sun reached its highest path, when days were longest, when nights were longest, and when the balance between day and night returned. It is hard to imagine now how powerful that discovery must have been, that the sky was not random, that the year had a pattern, that the future could be prepared for, because the heavens kept returning to themselves. The moon offered another kind of time. Unlike the sun, it changed its face night by night. A thin crescent became half, then full, then faded again into darkness. This cycle was visible, memorable, and emotionally powerful. Many early calendars were lunar or partly lunar because the moon made time countable in a way the sun alone did not. A month could be felt as a story in the sky. Appearance, growth, fullness, decline, disappearance, return. Some ancient marks carved into bones or stones have been interpreted by researchers as possible lunar counts, though such interpretations must be careful because we cannot always know exactly what the marks meant to the people who made them. Still, the idea is plausible and deeply human. When something repeats, the mind wants to mark it. A notch becomes a day. A series of notches becomes a cycle. A cycle becomes memory outside the body. This may be one of the earliest transformations in human timekeeping. Time moved from being something experienced to something recorded. Once you carve a mark for a day, you have created a physical trace of passing. You have made time visible. From there, human societies slowly built more complex systems. They watched the horizon. They aligned stones, monuments, tombs, and temples with solar or lunar events. Some ancient sites appear connected to solstices, equinoxes, or seasonal observations, though not every alignment should be exaggerated into mystery. The important truth is not that ancient people had secret supernatural knowledge. It is that they were patient observers. They watched the same sky for generations. They remembered where the sun rose on the longest day. They noticed which stars appeared before planting season. They passed that knowledge through story, ritual, architecture, and repeated practice. In many cultures, astronomy was not separate from religion, agriculture, leadership, and community life. To know the calendar was to know when to gather, when to plant, when to celebrate, when to mourn, when to prepare. Timekeeping became social power, because whoever understood the rhythms could help organize the future. This is why calendars were often tied to priests, rulers, temples, and ceremonies. A calendar is never just a list of days. It is a way of telling a society when life should happen. As civilizations grew, time needed to become more precise. Agriculture required seasonal prediction, but cities required coordination. Markets, rituals, work, law, taxes, travel, and administration all needed shared time. Sundials helped divide daylight into parts by using shadows, but they depended on sunlight and changed with season and latitude. Water clocks offered another solution. Water dripping or flowing at a steady rate could measure duration even when the sun was hidden. Ancient Egypt, Mesopotamia, China, Greece, and other civilizations developed different forms of timekeeping using shadows, water, stars, and eventually mechanical systems. None of these were perfect, but perfection was not the first goal. The first goal was agreement. A community needed a common rhythm. A farmer and a priest, a traveler and a guard, a ruler and a worker needed ways to share not just space, but timing. This is where time became more than nature's cycle. It became a human structure placed over nature. The day was divided. The month was named. The year was corrected when lunar cycles and solar seasons drifted out of alignment. Calendars became negotiations between sky and society. The moon does not fit neatly into the solar year. 12 lunar cycles are close to a year, but not exact. If a society follows only the moon, seasons slowly drift through the calendar unless adjustments are made. This created one of the great ancient challenges: how to make human time match celestial time closely enough for life to remain organized. Different cultures solved this in different ways, adding extra months, adjusting festivals, or building calendar systems that combined lunar and solar observations. This may sound technical, but underneath it is a profound human problem. The universe repeats, but not always in the simple units we wish it did. Nature gives rhythms, but humans must decide how to count them. That decision shapes culture. It shapes holidays, work, memory, history, and identity. When a society says, "This is the first day of the year," it is not only measuring astronomy, it is choosing a symbolic beginning. It is turning cosmic motion into meaning. And perhaps that is what ancient timekeeping really reveals. Humans did not measure time only because they wanted to know what hour it is. They measured time because they needed to belong to a world that kept changing. The sky could frighten them, feed them, guide them, or surprise them. Seasons could save or destroy. Floods could nourish fields or ruin homes. Winter could be endured if preparation began early enough. Timekeeping was a way of reducing uncertainty. It turned the future from a darkness into a pattern. Not a perfectly controlled pattern, but one that could be watched, remembered, and respected. Ancient humans learned that survival depended on noticing return. The return of dawn, the return of the moon, the return of rains, the return of cold, the return of stars in certain positions. And from that noticing came one of the deepest shifts in human consciousness. To measure time is to realize that your life is inside something larger than your own body. You are not only living from hunger to hunger, sleep to sleep, fear to fear. You are living inside cycles that began before you and will continue after you. The sun does not rise for one person. The moon does not change for one village. The seasons do not belong to one generation. Timekeeping taught humans humility and power at once. Humility because the sky was vast and indifferent. Power because its patterns could be learned. There is something quietly beautiful in imagining the first people who waited night after night, watching a star return to the same place, or noticing that a shadow had become short again after many days of lengthening. They did not have atomic clocks, telescopes, or equations, but they had patience, memory, fear, hunger, wonder, and the need to prepare. They turned observation into rhythm, rhythm into marks, marks into calendars, calendars into civilization. The first measurement of time was not a machine saying tick. It was a human being looking at the changing sky and realizing that the world had a pulse. And in some way, every clock since then still carries that ancient gaze. Every calendar on a wall, every alarm in a phone, every date written beside a plan, every birthday, every anniversary, every countdown is a descendant of someone watching light move across the ground, trying to understand when the next change would come. Ancient humans first measured time because they had to survive. But in doing so, they discovered something more than survival. They discovered that the universe remembers itself through repetition, and that by learning those repetitions, a fragile human life could find its place inside the enormous rhythm of the world. Why calendars are more strange than they look. Calendars look like simple boxes on a wall, but they are actually patched together agreements between astronomy, politics, religion, mathematics, and human impatience. You glance at a date and it feels solid. Monday, March 2026. A neat square in a neat grid, as if the universe itself has been divided into clean, human-sized pieces. But the sky does not naturally come in perfect months. The year does not contain a whole number of days. The moon does not fit politely into the solar year. The week does not arise from a simple physical law the way sunrise does. Even the months you use are uneven. carrying old decisions, ancient names, imperial edits, religious reforms, and mathematical corrections hidden beneath ordinary life. A calendar is not time itself. It is a negotiation with time, and the reason calendars are stranger than they look is that humans try to force several different cosmic rhythms into one tidy system, even though those rhythms do not line up cleanly. The day comes from Earth rotating once. The year comes from Earth orbiting the Sun. The month originally came from the Moon's cycle of phases. These three rhythms are real, visible, and important, but they do not divide evenly into one another. A solar year is roughly 365¼ days, but not exactly. A lunar cycle is about 29½ days, but 12 lunar months make only about 354 days, which is shorter than the solar year. That means if you follow only the moon, the months drift through the seasons. A month that once fell in spring can eventually move into winter. If you follow only the sun, the seasons stay aligned, but the moon's phases no longer match the month names perfectly. This is the ancient problem at the heart of calendars. The heavens keep more than one rhythm, and human society wants one schedule. Every calendar is therefore a compromise. Some calendars are mainly solar, keeping the year tied to the seasons. Some are lunar, following the moon closely. Some are lunisolar, adding extra months when needed to keep lunar months from drifting too far away from the seasons. None of this is arbitrary. It comes from the stubborn fact that nature's cycles are beautiful but inconvenient. The modern calendar used in much of the world, the Gregorian calendar, is a solar calendar designed to keep the calendar year close to the seasonal year. Its leap year rule is one of those hidden pieces of engineering most people use without noticing. Every 4 years, February gets an extra day because the year is longer than 365 days. But adding one day every 4 years adds slightly too much. So century years are not leap years unless they are divisible by 400. That is why the year 2000 was a leap year, but 1900 was not. This rule sounds strange until you realize what it is doing. It is correcting a correction. The universe did not give us a perfect 365-day year, so humans invented leap days. Then leap days created a smaller error, so humans refined the rule. A calendar is like a clock that must occasionally admit it has been lying by a little. Before the Gregorian reform, much of Europe used the Julian calendar, introduced under Julius Caesar. It also had leap years, but its year was slightly too long compared with the real seasonal year. The error was small each year, but small errors become history when you wait long enough. Over centuries, the calendar drifted away from the seasons. By the 16th century, the date of the spring equinox had shifted enough to become a serious problem for calculating Christian holy days, especially Easter. So in 1582, Pope Gregory III introduced a reform. To realign the calendar, several dates were skipped in countries that adopted the change. People went to sleep on one date and woke up with the calendar jumped forward. Time did not vanish from the universe, of course. The sun did not skip days. Human numbering did. This is one of the clearest reminders that calendar dates are not the same as cosmic time. A date is a label, and labels can be changed by authority. Different regions adopted the Gregorian calendar at different times, which means historical dates can be complicated depending on where an event happened and which calendar was being used. The same day could have different names in different places. That alone should make the calendar feel less like a natural object and more like a cultural machine. Even the shape of the months carries old layers. Why does February have 28 days most years? Why do some months have 30 days and others 31? Why are September, October, November, and December named like the 7th, 8th, 9th, and 10th months, when they are now the 9th, 10th, 11th, and 12th? The answer is history, not astronomy. The Roman calendar changed over time. Months were added, names remained, political figures were honored, and the structure evolved into something familiar enough that people stopped noticing its oddness. July is named after Julius Caesar. August is named after Augustus. The calendar is not only a tool for measuring time, it is a fossil of power. It carries rulers, reforms, religious priorities, agricultural needs, and administrative decisions inside the ordinary act of writing a date. Even the 7-day week is strange. It does not fit perfectly into months or years. A year does not contain an exact number of weeks, which is why dates shift weekdays from year to year. Your birthday does not always fall on the same day of the week because the grid does not lock neatly onto the orbit. The week is a human rhythm that became socially powerful through ancient planetary associations, religious traditions, and repeated use. It survives not because Earth orbits in sevens, but because society agreed to keep counting in sevens. That agreement is so strong that it shapes work, rest, worship, markets, school, and psychology. Monday can feel heavy not because the cosmos made Monday heavy, but because culture placed a pattern of obligation onto that square of time. Calendars do not merely describe life, they organize it. They tell you when to work, when to rest, when to celebrate, when to remember, when a year begins. When a person becomes legally older, when a deadline exists, when history is divided into before and after. This is why calendar systems can differ so deeply across cultures. The Islamic calendar is lunar, so its months move through the solar seasons over time. The Hebrew calendar is lunisolar, using adjustments to keep festivals connected with seasonal meaning. The Chinese calendar is also lunisolar, combining lunar months with solar terms. These systems are not primitive versions of one correct calendar. They reflect different priorities, religious cycles, agricultural timing, cultural memory, astronomical observation, and communal identity. To ask which calendar is real is to misunderstand what calendars do. The sky gives cycles. Humans decide which cycles matter most for their lives. There is another strangeness hidden in the idea of a year. A year can be defined in more than one way depending on what you measure. The time it takes Earth to return to the same position relative to the stars is not exactly the same as the seasonal year measured from one equinox to the next, because Earth's axis slowly wobbles over long periods. That difference is small, but it reveals how even something as basic as a year depends on the reference point you choose. Are you measuring against the stars? Against the seasons? Against the sun's apparent path? The answer matters. The calendar you live by is built to keep seasons stable, because seasons shaped agriculture, weather, and human survival. But the universe offers multiple ways to count, and none of them comes with a label saying, "Use this one." This turns the calendar into something quietly philosophical. It shows that human time is not pure nature and not pure invention. It is a bridge between the two. If calendars were pure invention, they could ignore the sun, moon, and seasons completely. If they were pure nature, every culture would use the same system effortlessly. Instead, calendars sit in the middle. They translate cosmic motion into social order. They take the turning Earth, the shifting moon, the returning seasons, and the needs of communities, then compress them into grids, names, numbers, holidays, and deadlines. That compression is useful, but it can also make time feel more rigid than it truly is. The universe does not know it is Tuesday. The galaxy does not pause because a month ends. The sun does not care that humans begin a new year on a chosen date. And yet those chosen dates shape real emotion. A new year can make people feel hope. An anniversary can reopen grief. A birthday can make age suddenly visible. A deadline can turn invisible future time into pressure inside the body. This is the strange power of calendars. They are invented labels that create real experiences. They are fiction with consequences, agreements so widely shared that they become part of reality. And maybe that is why calendars are more mysterious than they look. They remind you that humans do not only live in natural time. We live in named time, counted time, scheduled time, remembered time, time broken into boxes so the mind can hold what the cosmos never made neat. Behind every ordinary date is a hidden struggle to reconcile the messy elegance of the sky with the human need for order. So the next time you see a calendar, do not see only squares and numbers. See a quiet machine built from imperfect cycles, ancient reforms, skipped days, drifting moons, political names, seasonal corrections, and cultural memory. See humanity trying to make a home inside cosmic motion, drawing lines across time not because time came with lines, but because without them, we would not know where to meet, when to plant, when to mourn, when to begin again, or how to tell the story of our lives. The deep time, hidden beneath your feet. The ground beneath your feet is not still ground. It is the surface of a story so old that human history becomes almost too small to measure against it. You stand on pavement, soil, stone, sand, or tile and feel a stable world holding you up. But beneath that ordinary surface are buried oceans, vanished forests, crushed shells, ancient deserts, cooled lava, dead creatures, lifted seabeds, broken continents, and pressures that have been working long before any human voice named the sky. Deep time is the name we give to this almost unbearable scale of Earth's history. Not thousands of years, not millions in a casual sense, but billions of years of slow transformation layered beneath the present. The strange thing is that deep time is not hidden because it is far away. It is hidden because it is too close and too slow. You walk over it every day. You build roads on it, plant trees in it, drill into it, mine it, bury pipes through it, and rarely pause to realize that the ground is not a simple floor. It is an archive. A cliff face can be a book with pages made of sediment. A canyon wall can show different worlds stacked on top of one another. A riverbed, then a desert, then a shallow sea, then volcanic ash. Each layer recording a different environment that once existed where you are now. Sedimentary rocks are often made when tiny particles settle, press together, and harden over long periods. Sand can become sandstone. Mud can become shale. Shell fragments can become limestone. Each layer is a kind of frozen circumstance, a physical memory of water depth, wind direction, climate, chemistry, and life. If you touch a piece of limestone, you may be touching the remains of ancient marine organisms that lived in a sea that no longer exists. If you see coal, you are seeing the compressed legacy of ancient plant matter, often from swampy environments where dead vegetation accumulated and was buried before it fully decayed. If you stand on granite, you are near a rock that formed from molten material cooling slowly underground, crystallizing in darkness before erosion eventually revealed it. Rocks are not just substances. They are events that became solid. But Earth does not preserve its record neatly. It tears pages out. It folds them. It burns them. It buries them too deeply to read. Erosion can erase entire chapters. Mountain building can lift old seafloors into the sky. Heat and pressure can transform one rock into another until its original story becomes faint and difficult to decode. Plate tectonics slowly moves continents across the planet, opens oceans, closes oceans, builds mountain chains, triggers earthquakes, feeds volcanoes, and recycles parts of the crust back into the mantle. This means the ground beneath you is not a passive platform. It is part of a restless system, though its motion is usually too slow for human senses. A continent can drift only a few centimeters in a year, about the speed fingernails grow, and yet over millions of years that tiny motion can rearrange oceans and climates. What feels motionless in one lifetime can be migration on the scale of deep time. This is why geologists learn to see landscapes differently. A mountain is not simply a mountain. It may be the lifted and folded remains of ancient sediments, pushed upward by colliding plates. A valley may be carved by rivers, glaciers, or faults. A smooth plain may hide thousands of meters of layered rock beneath it. A desert may once have been a sea may one day become stone. Even the fossils inside rocks are not decorations. They are evidence of lives that existed in worlds with different coastlines, temperatures, atmospheres, and ecosystems. Fossils can show when certain organisms lived, how life changed, how extinctions reshaped the planet, and how environments shifted over time. Some fossils are useful for matching rock layers across different regions because certain species lived during specific intervals and spread widely. Through fossils, chemistry, and rock relationships, scientists can reconstruct pieces of Earth's past with remarkable care. They do not guess randomly. They read patterns. Which layer lies above another? Which rock cuts through which? Which minerals formed under which conditions? Which isotopes have changed at known rates? Which fossils appear together? Which magnetic signals were locked in when rocks formed? The result is not perfect knowledge of every ancient day, but a powerful, evidence-based picture of a planet that has never stopped becoming something else. And deep time changes the meaning of the present. The soil under a forest may be young compared with the bedrock below it. The bedrock may be young compared with the oldest minerals on Earth. The oldest known zircon crystals are over 4 billion years old, tiny survivors from a planet still forming its early crust. Earth itself is about 4.5 billion years old, a number so large that the human mind has to shrink it into metaphors just to approach it. If Earth's history were a single day, human civilization would arrive in the final moments before midnight. Yet those final moments feel enormous to us because we live inside them. This is the emotional shock of deep time. It does not make human life meaningless, but it changes its scale. Your worries, your cities, your languages, your borders, your monuments, all of them rest on a planet that has seen seas appear and vanish, continents split and collide, species rise and disappear, ice sheets advance and retreat, volcanoes build islands and destroy them, rivers carve stone grain by grain. The ground beneath you has outlived almost every story humans have told about it, and still, it is not eternal. Rock wears down, mountains erode, coastlines move, soil forms slowly and can be lost quickly. The stability you feel is temporary, just slower than your body can notice. This is why deep time is both humbling and strangely comforting. It reminds you that change does not always arrive as a crisis. Sometimes change is a pressure building for ages, a river cutting downward one season at a time, a shell settling to the seafloor, a layer of ash preserving a moment of eruption, a grain of sand traveling from mountain to river to ocean to stone. The present is not separate from this. You are living on the latest surface of an unfinished planet. Every step you take presses lightly on histories you cannot see. Beneath a city street may be an ancient river channel. Beneath a field may be the remains of a sea. Beneath a mountain trail may be rock that once formed deep underground, lifted slowly into air by forces too patient to feel. And perhaps that is the quiet lesson hidden beneath your feet. The world is not as young as it feels when you wake in the morning. It is not as fixed as it appears when you look at the horizon. It is a living record of time made solid, broken, buried, lifted, and read again by those willing to slow down enough to notice. Deep time does not speak loudly. It waits in stone. It waits in fossils. It waits in cliffs, caves, riverbeds, crystals, and dust. And when you finally listen, the ground stops being just the place you stand. It becomes the memory of a planet carrying you for a moment across the surface of its ancient, unfinished dream. Why everything you love exists only for a moment. Everything you love is temporary, not because the universe is cruel, but because love can only appear inside things that change. A face you know by heart is not the same face it was 10 years ago. A voice you recognize instantly is shaped by breath, age, mood, illness, laughter, silence, and all the invisible weather of a living body. A home feels like a fixed place until you realize its walls are slowly wearing. Its rooms are gathering dust. Its light is changing with every season. And the people who gave it meaning will never pass through it in exactly the same way twice. Even your own body, the one that feels like you, is not a permanent object. Cells are replaced, proteins are broken down and rebuilt. Skin renews, blood changes, bones remodel, memories are revised, and the chemistry of your inner life keeps shifting quietly beneath the story you call identity. You are not a statue moving through time. You are a process holding a shape for a while. And everything you love is like that too. Not a frozen possession, but a temporary pattern. This is hard to accept because the human mind is built to form attachments. It recognizes, names, remembers, protects, and returns. When something gives comfort or meaning, the mind wants it to stay. It wants the person to remain, the friendship to remain, the room to remain, the feeling to remain, the version of life that finally made sense to remain. But nature does not preserve things because we have named them. A flower is not a single still object. It is water moving through cells, sunlight transformed into sugar, genes expressing instructions, petals opening because of timing, temperature, and chemistry, then fading because the same life process that allowed it to bloom cannot hold that form forever. A human relationship is not a fixed object either. It is attention, communication, memory, trust, shared history, hormones, nervous systems, choices, and thousands of small repairs. A relationship exists only as long as it is being carried by living people who are themselves changing. Even a mountain, which seems almost eternal compared with a human life, is temporary on the scale of Earth. Rain cuts it, wind wears it, ice cracks it, roots enter it, rivers carry its grains away, and tectonic forces may lift or break it over ages. Permanence is often only slowness seen from a short life. The reason everything you love exists only for a moment is that form itself is temporary. Matter can remain, energy can move, atoms can be reused, but the exact arrangement, the face, the song, the afternoon, the childhood house, the hand in yours, the person you were when it happened, does not stay assembled forever. This does not mean love is an illusion. It means love belongs to patterns, not to permanence. When you love a person, you are not loving an unchanging substance. You are loving a living pattern. The way they smile when tired, the way they think, the way their presence changes a room, the history you share, the future you imagine, the fragile continuity of their being from one day to the next. But that pattern is never locked. It is being updated by sleep, stress, time, illness, learning, disappointment, joy, and every experience that leaves a mark. This is why you can miss someone even while they are still alive. The person may be there, but a version of them is gone, or a version of you is gone, or the space between you has changed. Loss does not only arrive at death. Loss happens in small, invisible ways whenever a moment cannot be returned to exactly. Childhood ends before you understand what it was. A friendship changes tone before anyone admits it. A city becomes unfamiliar street by street. A favorite song stops feeling the same because you no longer belong to the life in which you first heard it. Time does not only take things away, it alters the relationship between you and the things that remain. This is why nostalgia can hurt so strangely. You may not only want the old place back, you may want the old self who could stand inside that place without knowing it would become memory. Science gives this feeling a physical foundation. The brain does not store experience as perfect living reality that can be re-entered untouched. It stores traces, associations, emotional tones, sensory fragments, and meanings. When you remember something you loved, your brain rebuilds it from what remains. That memory can be vivid, but it is not the moment itself returning. It is the nervous system creating a present echo of an absent pattern. The person is not fully there. The day is not fully there. The light is not fully there. Yet something real survives as a trace, and that trace can still move you. This is one of the gentlest and most painful facts of being alive. Love can outlast the form it loved, but it cannot restore the form exactly. You can keep the meaning, but not the moment. You can keep the photograph, but not the air around the photograph. You can keep the voice recording, but not the living pause before the person spoke. You can keep the lesson, but not the hour in which you learned it. And still, none of this makes the original moment less valuable. In fact, impermanence may be part of why value exists at all. If every beautiful thing stayed forever, unchanged and always available, the mind might stop noticing it. Attention is awakened by rarity, by change, by the knowledge that this arrangement is not guaranteed. A meal matters because hunger returns. A sunrise matters because the sky changes. A conversation matters because the words cannot be unsaid in the same way twice. A life matters because it is bounded. The boundary does not erase meaning, it concentrates it. You do not love a song less because it ends. The ending is part of what lets the song become whole. A note held forever would stop being music. Music needs change, silence, return, tension, release, and disappearance. Perhaps life is similar. A moment becomes meaningful because it rises, exists briefly, and passes into memory, leaving the mind altered. The strange thing is that humans often try to defeat impermanence by holding tighter. But gripping can make the moment harder to feel. When you are afraid of losing something, part of your attention leaves the present and moves ahead into imagined absence. You begin mourning while the thing is still here. You look at a person and think of a future without them. You enter a beautiful day and begin measuring how soon it will end. This is understandable, but it steals from the very experience you are trying to protect. The answer is not to pretend things last. The answer is to let their temporary nature sharpen your presence rather than poison it. To know that the moment will pass and still fully enter it. To understand that the person will change and still meet them as they are today. To see that your own life is moving and still care for the hour in your hands. There is a deep biological truth here as well. Living systems survive by renewal, not by remaining the same. If your body tried to preserve every cell exactly as it was, it would not stay alive. It would fail to repair, adapt, learn, and respond. Change is not only the cause of loss, it is also the condition of growth. The child becomes the adult because one form gives way to another. A wound heals because tissue changes. A mind matures because old assumptions loosen. A forest renews through cycles of growth, decay, and return. The world is not made of permanent things with occasional change added on top. It is made of change that briefly takes recognizable shapes. You call one shape a tree, one shape a friend, one shape a home, one shape yourself. The names are useful and the love is real, but the shapes are always in motion. This can feel heartbreaking if you hear it only as loss. But there is another way to hear it. If everything you love exists only for a moment, then each moment is not a disposable fragment on the way to something better. It is the actual place where life appears. Not later, when everything is secure. Not someday when nothing can be lost. Not in a perfect future where all beloved things remain unchanged. Life is occurring in these temporary arrangements. The breath before sleep, the ordinary meal, the message you almost ignored, the familiar face under changing light, the body carrying you through one more day without asking to be praised. You do not need eternity for something to be real. A snowflake is real before it melts. A wave is real before it folds back into the sea. A childhood afternoon was real even though no road can take you there now. Your love was real even if the person changed, left, or died. Reality does not require permanence. It requires existence, however brief. And perhaps this is the soft conclusion hidden inside the hardest truth. Everything you love exists only for a moment, because moments are the only place love can enter the world. Love cannot touch a timeless object. It needs a living face, a passing voice, a changing body, a fragile day, a risk of absence. It needs time, and time means transformation. So the task is not to keep everything forever. The task is to recognize what is here while it is here, to care without the fantasy of possession, to let gratitude become stronger than fear, and to understand that temporary does not mean meaningless. It means unrepeatable. It means this exact arrangement of matter, feeling, light, memory, and presence has appeared once in the vastness, and for a little while, you were awake enough to love it.